Hide the planet! Hide the planet!
Shut up and get in.
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, Hacker Frogs. It's me, the Shy Hat, and we're here to do HackerFrogs AfterSchool today. We're here to do HackerFrogs free hack, and we're hacking all the things. So let's talk about what we're going to be covering today. So on each one of our live streams, we like to cover a bunch of different topics. And these are the topics for today. Today is Web App Wednesday, and it is Wednesday, May 20th, 2026. So the first thing we're going to be doing is we're going to be warming up with a little topic. We're going to be learning about AI. I'm taking a little bit of an AI course, and we're going to be talking about all that great AI stuff because we need to learn about that to understand what's coming in the future because, well, it seems like we're not going to stop talking about AI, so we might as well learn about it. The second topic we're going to be covering today is PicoCTF 2026. This is a famous cybersecurity CTF event that happens every year, and we're going to be covering some of the web app hacking challenges. We're going to be doing some demos of those, and I'm going to try to explain as best as I can how exactly these challenges go and what kind of technologies are involved. So that's the second topic for today. In the third topic, we're going to be doing HackerFrogs AfterSchool. HackerFrogs AfterSchool is a program that I came up with to teach people about basic cybersecurity concepts. Today we're going to be covering digital forensics, and we're going to be talking about disk image forensics. So if you're interested in learning about how to get information out of those disk images, then this is going to be the topic for you. That's the third topic. And in the fourth topic, we're going to be doing a challenge. So the challenge today is we're going to be doing a CTF box, which is called Bank. So we're going to be hacking into a bank, supposedly. And we're going to be doing that challenge from the Vulnyx platform. Vulnyx is a platform where you can download virtual machines to deploy on your networks and then do your hacking against those machines until you get total access to the machine. So that's going to be the last challenge for today. So let's go ahead and get into our first topic. Our first topic is going to be about an hour, and we're going to be talking about AI stuff. So let's just set up that timer, and then we'll get going. Okay, let's see. As someone that's hacked banks, I'll tell you it's accurate. As someone who's hacked banks, I'll tell you that it's accurate. Sick in the mind, have you done the bank box from Vulnyx? Or are you referring to something else? Okay, so let's go ahead and start our first topic. Oh, okay, not that box in particular. All right, let's go ahead and do this course. So we're going to be talking about advanced neural network techniques today. Okay, so Sick in the Mind says, I've done pen testing for real banks, and so when you're talking about the pen testing for real banks, were you taking it from the perspective of getting in through the web portal or through like web accessible parts of the network, or are we talking about them giving you access to their Windows Active Directory network? Both? Oh, okay. So you've done both the network side and the web app side. Awesome, awesome. All right, so everybody, if you want to do the same stuff that we're doing, external, internal, and post-breach. Post-breach, okay, or walking in demanding money. That's probably the most secure the bank is going to be, because they're most prepared for people coming in and demanding money. That's why they usually have scary people with guns standing around the bank. Anyways, let's talk about these neural networks. So we're talking about advanced neural network techniques or assumed breach. I mean, that's also pen testing. SysOS Master, you are correct. I would not want to do physical pen testing on a bank because, well, it's very likely to have people wandering around with guns. So, yeah. Anyways, I'd rather stick to the electronic approach, but it is also pen testing. That's true. Okay, we've got ads in progress right now. So because we've got ads on Twitch, we'll also do ads on, well, we'll also take a little break and we'll put on some birds. So this is, let's do a clip that we haven't done for a while. How about these happy birds over here? Okay, so we'll be back in about 60 seconds when the ads run out on Twitch. Okay, Sick of the Mind says, I also take a physical pass on Indian reserve casinos. I mean, the laws have to be, well, laws are kind of different as far as Indian reserves are concerned in the United States. So I'm not an expert on that. They have automatic weapons. Yeah, that's kind of scary. Okay, I'm just going to have a little sip of water, then we'll come back. Okay, I'm pretty sure these are all house what were they called? House sparrows over here. Anyways, let's put the birds away. We'll get back to what we were doing. Okay, David Ferguson asks, I hear a lot about quantum computing with AI. How does it affect cybersecurity and hacking? Quantum computing with AI? Well, I mean, we know that when quantum computing actually arrives, it'll make a lot of cryptography. It'll be able to break a lot of cryptography because there are different degrees of cryptography, some of which is quantum safe, and some of which is not quantum safe. So the stuff that was encrypted with non-quantum safe algorithms, that's going to be able to get cracked when the quantum computing becomes available. I'm pretty sure that the first people who are going to get access to quantum computing are going to be governments, but eventually, well, I mean, I'm not super knowledgeable about quantum computing in the first place, but that is some stuff I've heard. Okay, anyways, let's go ahead and talk about these neural network techniques. In the previous section, we've discussed the basic ideas behind most neural network methods, multi-layer networks, nonlinear activation functions, and reading and learning rules such as the back propagation algorithm. So they power almost all modern neural network applications. However, there are some interesting and powerful variations of the theme that have led to great advances in deep learning in many areas. So let's talk about what these are. Convolutional neural networks, or CNNs. One area where deep learning has achieved spectacular success is image processing. The simple classifier that we studied in detail in the previous section is severely limited. As you noticed, it wasn't even possible to classify all the smiley faces correctly. Adding more layers in the network and using backpropagation to learn the weights does, in principle, solve the problem. But another one emerges. The number of weights becomes extremely large, and consequently, the amount of training data required to achieve satisfactory accuracy can become too large to be realistic. Fortunately, a very elegant solution to the problem of too many weights exists, a special kind of neural network, or rather, a special kind of layer that can be included in a deep neural network. This special kind of layer is the so-called convolutional layer. Networks including convolutional layers are called convolutional neural networks, or CNNs. Their key property is that they can detect image features such as bright or dark, or specific color spots, edges in various orientations, patterns, and so on. These form the basis for detecting more abstract features such as a cat's ears, a dog's snout, a person's eye, or the octagonal shape of a stop sign. It would normally be hard to train a neural network to detect such features based on the pixels of the input image, because the features can appear in different positions, different orientations, and in different sizes of the image. Moving the object or the camera angle will change the pixel values dramatically, even if the object itself looks just the same to us. In order to learn to detect a stop sign in all these different conditions would require vast amounts of training data, because the network would only detect the sign in conditions where it has appeared in the training data. So, for example, a stop sign in the top right corner of the image would be detected only if the training data included an image with the stop sign in the top right corner. CNNs can recognize the object anywhere in the image, no matter where it has been observed in the training images. Alright, so why do we need CNNs? So CNNs use a clever trick to reduce the amount of training data required to detect objects in different conditions. The trick basically amounts to using the same input weights for many neurons, so that all of these neurons are activated by the same pattern, but with different input pixels. We can, for example, have a set of neurons that are activated by a cat's pointy ear. When the input is a photo of a cat, two neurons are activated, one for the left ear and another for the right. We can also let the neuron's input pixels be taken from a smaller or larger area, so that different neurons are activated by the ear appearing in different scales or sizes. So that we can detect a small cat's ears even if the training data only included images of big cats. So the convolution neurons are typically placed in the bottom layers of the network, which processes the raw input pixels. Basic neurons, like the perceptron neuron discussed above, are placed in the higher layers, which processes the output of the bottom layers. The bottom layers can usually be trained using unsupervised learning without a particular prediction task in mind. Their weights will be tuned to detect features that appear frequently in the input data. Thus, with photos of animals, typical features will be ears and snouts, whereas in images of buildings, the features are architectural components such as walls, roofs, windows, and so on. If a mix of various objects and scenes are used in the input data, then the features learned by the bottom layers will be more or less generic. This means that the pre-trained convolutional layers can be reused in many different image processing tasks. This is extremely important, since it is easy to get virtually unlimited amounts of unlabeled training data. Images without labels, which can be used to train the bottom layers. The top layers are always trained by supervised machine learning techniques such as back propagation. So here, I guess we're teaching the system to differentiate between a cat's head and a stop sign. All right? So, do neural networks dream of electric sheep? Generative adversarial networks, or GANs. Having trained a neural network on data, we can use it for predictions. Since the top layers of the network have been trained in a supervised manner to perform a particular classification or prediction task, the top layers are really useful only for that task. A network trained to detect stop signs is useless for detecting handwritten digits or cats. A fascinating result is obtained by taking the pre-trained bottom layers and studying what the features they have learned look like. This can be achieved by generating images that activate a certain set of neurons in the bottom layers. Looking at the generated images, we can see what the neural network thinks a particular feature looks like, or what an image with a select set of features in it would look like. Some even like to talk about the network's dreaming or hallucinating images. See Google's Deep Dream system. Okay, so it says, do androids dream of electric sheep? Classic sci-fi. Yeah, so that short story was used as the basis for the Blade Runner film. And I have listened to the audiobook of Do Androids Dream of Electric Sheep, and it was a really interesting. Are my comments going through? Hebrew, hello, nice to see you. Yeah, the comments are going through, and I'm pretty sure I answered one of your messages earlier. Anyways, okay, so be careful with metaphors. However, we'd like to once again emphasize the problem with metaphors such as dreaming with simple optimization of the input image is meant. Emphasize the problem with metaphors such as dreaming when simple optimization of the input image is meant. Remember the suitcase words discussed in chapter 1. The neural network doesn't really dream, and it doesn't have a concept of a cat that it would understand in a similar sense as a human understands. It is simply trained to recognize objects, and it can generate images that are similar to the input data that it is trained on. Okay, Fox says, is it normal if I don't understand something in CTF and then research and understand it? This is normal. So Fox, you're talking about coming across something that you haven't seen in a CTF. So CTF challenge, encounter a system or software you aren't familiar with. Then you do some research how the system/software works. And then you figure out how to, what is the word? How to exploit the system. This is a regular thing in learning how to hack. Okay, I feel like I'm cheating. You don't have to feel like you're cheating. You just need to learn how to do your research. If you don't know how to do research, if you don't know how to figure out how a system works or what it's all about, then you're not able to exploit the system. I mean, sometimes you can interact with the system and exploit it without understanding how it works, but that's not the regular way. That's not the regular way. The regular way is to understand how the system works first and then exploit it. Okay, let's continue. All right, so to actually generate real-looking cats, human faces or other objects, you'll get whatever you used as the training data. Ian Goodfellow, a researcher at Google Brain at the time, proposed a clever combination of two neural networks. The idea is to let the two networks compete against each other. One of the networks is trained to generate images like the ones in the training data. It is called the generative network. The other network's task is to separate images generated by the first network from real images from the training data. This one is called the adversarial network. These two combined then make up a generative adversarial network, or a GAN, or a GAN. And here we are at the GAN. They are cool. Yeah, well, I mean, I'm excited to find out what these things are. Okay, so let's see. So the system trains the two models side by side. In the beginning of the training, the adversarial model has an easy task to tell apart the real images from the training data and the clumsy attempts by the generative model. However, as the generative network slowly gets better and better, the adversarial model has to improve as well, and the cycle continues until eventually the generated images are almost indistinguishable from the real ones. So the GAN tries to not only reproduce the images in the training data, that would be a way too simple strategy to beat the adversarial network. Rather, the system is trained so that it has to be able to generate new, real-looking images too. Okay, so we've got pictures of people. So I'm guessing that the generative network is trying to generate images that will fool the adversarial network into thinking that they're the training data. So the above images were generated by a GAN developed by NVIDIA in a project led by Professor Jaakko Lehtinen. I'm not too sure how to pronounce that. Could you have recognized them as fakes? Okay, so are these fake photos? So I mean, now that you've been told that these are fake photos, there is an amount of artifacting, especially in the background elements of the image, that could identify these as potential deepfakes or generated images. So you see here that there's some blurriness in the backgrounds. You can also see that when you were dealing with hair, sometimes the hair has some weird edges. But yeah, the focus is really weird on all of these images, and the hair in this image is kind of wonky. Sick in the Mind says Christina Aguilera and Jennifer Aniston. The right side is definitely two other actors. There's artifacts from other photos, from other real photos. Robert De Niro, another actor on the right side. So I mean, yeah, I'm not super familiar with these Hollywood types, but it does seem very plausible. Okay, so the rise of large language models, LLMs. So this is especially relevant to what we're dealing with today because a lot of the AI that we talk about these days is all LLMs. Okay, as mentioned above, convolutional neural networks, CNNs, reduce the number of learnable weights in a neural network so that the amount of training data required to learn all of them doesn't grow astronomically large as we keep building bigger and bigger networks. Another architectural innovation, besides the idea of a CNN, that currently powers many state-of-the-art deep learning models is called attention. Attention is a special term? Interesting. Okay, just a second, everybody. I just realized that I don't have any music playing right now, so I might as well put on some music in the background so that we've got a little something to listen to. Okay, let's see if we can lower the volume a little bit. Okay, let me know if the volume of the music is distracting, because I definitely don't want it to be distracting. And if it's a little bit too soft, let me know as well, because it should be in the background but not overwhelming. Anyways. Attention mechanisms were originally introduced for a machine translation where they can selectively focus on the attention of the model of certain words in the input text when generating a particular word in the output. Okay, sounds okay, that's good, that's great. This way the model doesn't have to pay attention to all of the input at the same time, which greatly simplifies the learning task. Attention mechanisms were soon found to be extremely useful, not only in machine translation. Okay, in 2017, a team working at Google published the blockbuster article, Attention is All You Need, which introduced the so-called transformer architecture for deep neural networks. Unless you've been living on a desert island or in an otherwise strict media diet, you have most likely already heard about transformers, the neural network models, not the toy franchise. So, neural network transformers, I mean, I can't say that I know very much about this particular term. It's just that they may have been hiding inside an acronym, GPT, Generative Pre-trained Transformer. Okay, so GPT has the word transformer in it, so we need to pay attention to this. As part as the title of the article by the Google team suggests, transformers heavily exploit attention mechanisms to get the most out of available training data and computational resources. Okay, good to hear. You've heard of these transformers? So the most widely noted applications of transformers are found in large language models, or LLMs. The best known ones are OpenAI's GPT series, including GPT-1, released in June 2018, and GPT-4, announced in March of 2023. But no giant platform company wants to miss out. Google picks model names from Sesame Street and published BERT, bidirectional encoding representations from transformers in October 2018, while Meta joined the party a bit later in February 2023, picking a name inspired by the animal world, Llama, Large Language Model Meta AI. And it's not just the platform companies that are driving the development. Universities and other research organizations are contributing open source models with the goal of democratizing the technology. Okay, so it's hard to imagine that that LLM technology that we're all talking about and is all the rage in the news these days is not actually very old. So March 23rd was GPT-4. I'm pretty sure that that AI became pretty common by the end of 2022. So we're only about 4 years. Well, we're not even 4 years into the whole like AI. What do we call it? Like a hype cycle or something like that. Okay, I believe HRM is the future of AI. What is HRM? Can you tell me about that? Oh, hierarchical reasoning models. Sapience HRM. It is only 27 million parameters, but it is competes with much bigger LLMs in benchmarks such as older Claude, Gemini, and ChatGPT models. I mean, I'm not an AI expert by any means. That's why I'm taking a course right now. But it is something that we're all going to have to learn about in order to keep up with all of the AI stuff in the future. Okay. You can run HRM on your computer. I mean, can you run it on any old computer? I mean, you can run a bunch of different open source LLM models on your typical laptop as well. It's just that the power or how powerful the model is really depends on how much memory and how much compute that it has. Okay. So Sick in the Mind says, just like the girls in Hidden Figures, we're going to have to learn a new beast if we want to stay on the forefront of tech. You can run an LLM on your computer. That's not a qualifier that says anything. Yeah, you can run an LLM on your computer, whether or not that LLM is going to be as powerful as the LLMs that run in the cloud, that you have web access to. That's a completely different thing. Okay, so let's define the word LLM. So what is an LLM? LLMs are models that, given a piece of text like the capital of Finland, predicts how the text is likely to continue. In this case, Helsinki, or a pocket-sized metropolis, would be likely continuations. The capital of Finland is a pocket-sized metropolis? Interesting. Or the capital of Finland is Helsinki, which is a bit more intuitive. LLMs are trained on large amounts of text, such as the entire contents of Wikipedia, or the Common Crawl dataset, that at the time of writing this contains a whopping 260 billion web pages. Okay, let's see. Heber says you can run it on HRM on most modern personal computers. It's different and better than other local models. I mean, do you have an HRM model that you can recommend? Okay, so in principle, one can view LLMs as basically nothing but extremely powerful predictive text entry techniques. However, with some further thinking, it becomes apparent that being able to predict the continuation of any text in a way is indistinguishable from human writing is, or would be, quite a feat and encompass many aspects of intelligence. The above example, which is based on the association between the words the capital of Finland and Helsinki, is an example where the model has learned a fact about the world. If we'd be able to build models that associate the commonly agreed answers to a wide range of questions, it could be argued that such a model has learned a big chunk of so-called world knowledge. Especially intriguing are instances where the model seems to exhibit some level of reasoning beyond memorization and statistical co-occurrence. Currently, LLMs are able to do this in a limited sense, and they can easily make trivial mistakes because they are based on just statistical machine learning. Intensive research and development efforts are directed at building deep learning models with more robust reasoning algorithms and databases of verified facts. Okay, so let's see. There is only, so Heber says, there's only one HRM model right now. There is only one HRM model right now. What is the name of the HRM model? Just for reference. Okay, so I guess we're going to be talking about ChatGPT. So ChatGPT was probably the most well-known LLM model that people were using back in the early days. So ChatGPT AI for the masses. So a massive earthquake occurred in San Francisco on November 30th, 2022. It was so powerful that hardly a person on the planet was unaffected, and yet no seismometer detected it. The metaphorical earthquake was the launch of ChatGPT by OpenAI. That's great. So they say that this was an earthquake, and it's ChatGPT is the earthquake. That's great. Okay. So word of the online chatbot service that anyone could use free of charge quickly spread around the world, and after mere 5 days, it had more than 1 million registered users. Compare this to the 5 years that it took Element of AI to reach the same number. And in 2 months, the number of signups was 100 million. No other AI service, or probably any service whatsoever, has become a household name so quickly. The first version of ChatGPT was based on a GPT 3.5 model, fine-tuned by supervised and reinforcement learning, according to a large number of human-rated responses. The purpose of the fine-tuning process was to steer the model away from toxic and incorrect responses that the language model had picked up from its training data, and towards comprehensive and helpful responses. Okay, so let's catch up with chat. SysOS Master says HRM is the alternative to chain of thought, which fine you could do, but it's not magic and only dealing with one aspect of AI processing. Okay, SysOS Master says, okay, we've got some links. So Sapient Inc. HRM seems to be the source, and it is a corporate website. Oh, Sapient Inc. Interesting. Well, the link is in chat if you want to check it out yourself. Okay, so let's talk more about ChatGPT. It is not easy to say what caused the massive media frenzy and the unprecedented interest towards ChatGPT by pretty much everyone, even those who hadn't paid much attention to AI thus far. Probably some of it is explained by the somewhat better quality of the output due to fine-tuning and the easy-to-use chat interface, which enables the user not only to get one-off answers to isolated questions, like any of the earlier LLMs, but also maintain a coherent dialogue in a specific context. In the same vein, the chat interface allows one to make requests like, explain this to a 5-year-old, or write this song in the style of Nick Cave. Mr. Cave, however, wasn't impressed. In any case, ChatGPT succeeded in bumping the interest of AI to completely new levels. No. SysOS Master is not a bot, although it does sound like a name that a bot could have, but he's definitely a person. Okay, so what are we talking about? So it remains to be seen what are the real killer apps for ChatGPT and other LLM-based solutions. We believe the most likely candidates are the ones where the factual content comes from the user or from another system, and the language model is used to format the output in the form of language, either natural language or possibly formal language, such as program code. We'll return to the expected impact of ChatGPT and other LLM-based applications in the final chapter. After completing Chapter 5, you should be able to explain what a neural network is and where they are being successfully used, and understand the technical methods that underpin neural networks. Okay, so let's see. Please join the Elements of AI community to discuss and ask questions about this chapter. You've reached the end of Chapter 5. So we gave 56% correct answers. That's not very great, but I guess we can keep on learning. Next chapter is implications. So we got about 30 minutes to read about this chapter. Let's begin. Okay, so I believe that the more you know about the past, the better you are prepared for the future. And that's a quote by Theodore Roosevelt. In Chapter 6, we will cover the following sections. Click below to get started. We've got about predicting the future, the social implications of AI, and our summary. Okay, so this is Chapter 6. I'm pretty sure this is the last chapter of the course. And after we finish this course, I'm not sure whether or not we're going to be starting another course. They've got 2 courses on AI on this particular website. But let's begin the first section here, about predicting the future. Okay, so we will start by addressing what is known to be one of the hardest problems of all, predicting the future. You may be disappointed to hear this, but we don't have a crystal ball that would show us what the world would be like in the future and how AI will transform our lives. As scientists, we are asked to provide predictions, and our refusal to provide any is faced with a roll of the eyes, boring academics. But in fact, we claim that anyone who claims to know the future of AI and the implications it will have on our society should be treated with suspicion. Okay, and what do we have here? We've got a person being tended to by a robot servant. Okay? The reality distortion field. Not everyone is quite as conservative about their forecasts. However, in the modern world, where big headlines sell, and where you have to dissect news into 280 characters, reserved or boring messages are lost, and simple and dramatic messages are magnified. In the public perception of AI, this is clearly true. So they're talking about 280 characters. They're clearly making a reference to Twitter or X here. All right, so everybody, we're just going to take a little break because there's an ad running on Twitch right now. And while the ads are running, we'll put on the birds. All right, so what do we got? We got some birds, and they're flying around and eating some peanuts. We'll be back in about 50 seconds. I just need to have a little bit of a water break. So sometimes these birds, they take too many peanuts at the same time, and so they can't close their mouths properly, and it can be a very funny thing to watch. Anyways, let's get back to AI. Okay, so we're talking about how predicting the future is something that smart people don't really want to do, but other people do want to do because they want to amplify their messages in social media circles such as Twitter or X. So let's talk about it. So from utopian visions to grim predictions, the media sphere is dominated by the extremes. We are beginning to see AI celebrities standing for one big idea and making oracle-like forecasts about the future of AI. The media loves their clear messages. Some promise us a utopian future with exponential growth and trillion-dollar industries emerging out of nowhere. True AI that will solve all problems we cannot solve by ourselves, and where humans don't need to work at all. Okay, let's catch up with chat. You never know these days. I guess the only way to know it if a user makes mistakes, but even a machine can simulate that. I mean, being able to tell whether or not you're interacting with a bot is I think it's a very important skill set to have, but it's not something you can tell right away. You'd have to observe your interactions with the quote-unquote bot for an extended amount of time, and look for other clues as well to be able to tell whether or not you're talking to people. AI, and that AI is a threat to our existence. Second of Mine says, the best news I've heard this week was a township in Missouri that approved a $6 billion AI data center, voted out every single person who approved the project. What is that? So a township in Missouri approved a $6 billion AI data center, which was voted out by every single person who approved. So I dropped off Twitch completely for a moment. Really? The YouTube stream is healthy, but yeah, I seem to have reset my stream on Twitch. That's weird. Anyways, we'll continue. So, are we saying that the data center is going to go through, or is the data center not going to go through? Second of Mine, let me know. Okay, so while some forecasts will probably get at least something right, others will likely be useful only as demonstrations of how hard it is to predict, and many don't make much sense. What we would like to achieve is for you to be able to look at these and other forecasts and to be able to critically evaluate them. Okay, Second of Mine says the entire community got every approving member of the city council voted out of their position by approving the data center against the city's wishes. Oh, okay. So so does that mean the data center is going to go through, but they also got rid of all the city councilors? Or is the data center not going through? Nobody wants new data centers near them. I mean, that makes a lot of sense. There's going to be a lot of disruptive impact because there's going to be a lot of construction, and there's going to be a lot of, well, noise pollution and other types of unforeseen stuff as well. Okay, so let's talk about hedgehogs and foxes. The political scientist Philip E. Tetlock, author of Super Forecasting: The Art and Science of Prediction, classifies people into two categories: those that have one big idea, hedgehogs, and those that have many small ideas, foxes. Second of Mine says light pollution, humming nearby, draining water resources, and increasing local temperatures. Yeah, there's going to be a lot of consequences of living near big AI data centers. Tetlock has carried out an experiment between 1984 and 2003 to study factors that would help us identify which predictions are likely to be accurate and which are not. One of the significant findings was that foxes tend to be clearly better at prediction than hedgehogs, especially when it comes to long-term forecasting. Okay, so while we're talking about people, right? We're not talking about literal foxes and hedgehogs. We're just talking about types of people who have small ideas, many small ideas, or one big idea. I mean, what do we actually mean by one big idea versus many small ideas? Probably the messages that can be expressed in 280 characters are more often big and simple hedgehog ideas. Our advice is to pay attention to carefully justified and balanced information sources, and to be suspicious about people who keep explaining everything using a single argument. Predicting the future is hard, but at least we can consider the past and present. We can consider the past and present AI, and by understanding them, hopefully be better prepared for the future, whatever it turns out to be like. Okay, so we got hype, the cycle of hype. The history of AI, just like many other fields of science, has witnessed the coming and going of various different trends. In the philosophy of science, the term used for a trend is paradigm. Okay, so a trend in science is known as a paradigm. Typically, a particular paradigm is adopted by most of the research community and optimistic predictions about progress in the near future are provided. For example, in the 1960s, neural networks were widely believed to solve all AI problems by imitating the learning mechanisms in nature, the human brain in particular. The next big thing was expert systems based on logic and human-coded rules, which was the dominant paradigm in the 1980s. Okay, so a paradigm is a scientific word for a trend. This is what we're supposed to understand here. Okay, and then AI winters. In the beginning of each wave, a number of early success stories tend to make everyone happy and optimistic. The success stories, even if they may be in restricted domains, and in some ways incomplete, becomes the focus of public attention. Many researchers rush into AI, or at least calling their research AI, in order to access the increased research funding. Companies also initiate and expand their efforts into AI in the fear of missing out, otherwise known as FOMO. Okay, SysOS Master says a paradigm is a type of trend. Okay, so far, each time an all-encompassing general solution to AI has been said to be within reach, progress has ended up running into insurmountable problems, which at the time were thought to be minor hiccups. In the case of neural networks in the 1960s, the hiccups were related to handling nonlinearities and to solving the machine learning problems associated with the increasing number of parameters required by neural network architectures. In the case of expert systems in the 1980s, the hiccups were associated with handling uncertainty and common sense. As the true nature of the remaining problems dawned after years of struggling and unsatisfied promises, pessimism about the paradigm accumulated and an AI winter followed. Interest in the field faltered and research efforts were directed elsewhere. Okay, so what is this modern AI? And we've got another ad running on Twitch. Alright, I guess we'll stop for a little bit and put on the birds. We'll be back in about 1 minute. But check out these guys. Are you coming in? Here we go. Okay, we'll be back in about 45 seconds. Okay, we'll put the birds away and we'll get back to the learning. So what is this modern AI? So currently, roughly since the turn of the millennium, AI has been on the rise again. Modern AI methods tend to focus on breaking a problem into a number of smaller, isolated, and well-defined problems and solving them one at a time. Modern AI is bypassing grand questions about meaning of intelligence, the mind, and consciousness, and focusing on building practical, useful solutions in real-world problems. Good news for us all who can benefit from such solutions. Another characteristic of modern AI methods, closely related to working in the complex and messy real world, is the ability to handle uncertainty, which we demonstrated by studying the uses of probability in AI in Chapter 3. Finally, the current upwards trend of AI has been greatly boosted by the comeback of neural networks and deep learning techniques capable of processing images and other real-world data better than anything we have seen before. Okay, so are we in a hype cycle? Whether the history will repeat itself and the current boom will once again be followed by an AI winter is a matter that only time can tell. Even if it does, and the progress towards better and better solutions slows down to a halt, the significance of AI in the society is going to stay. Thanks to the focus on useful solutions to real-world problems, modern AI research yields fruit already today. Rather than trying to solve the big questions about general intelligence first, which was where the earlier attempts failed. Prediction 1. AI will continue to be all around us. As you recall, we started by motivating the study of AI by discussing prominent AI applications that affect all our lives. We highlighted 3 examples: self-driving vehicles, recommendation systems, and image and video processing. During the course, we have also discussed a wide range of other applications that contribute to the ongoing technical transition. AI making a difference. As a consequence of focusing on practicality rather than the big problems, we live our life surrounded by AI, even if we may most of the time be happily unaware of it. The music we listen to, the products we buy online, the movies and series we watch, our routes of transportation, and even the news and information that we have available are all influenced more and more by AI. What is more, basically any field of science, from medicine to astrophysics to medieval history, is also adopting AI methods in order to deepen our understanding of the universe and of ourselves. Prediction 2. The Terminator isn't coming. One of the most pervasive and persistent ideas related to the future of AI is the Terminator. In case you have somehow missed the image of a brutal humanoid robot with a metal skeleton and glaring eyes, well, that's what it is. The Terminator is a 1984 film by director James Cameron. In the movie, the global AI-powered defense system called Skynet becomes conscious of its existence and wipes out most of humankind out of existence with nukes and advanced killer robots. So if you haven't seen the movie Terminator and Terminator 2, they're really good movies, and you should go check them out. Anyways, 2 doomsday scenarios. There are 2 alternative scenarios that are suggested to lead to the coming of the Terminator or other similarly terrifying forms of robot uprising. In the first, which is the story from our 1984 film, a powerful AI system just becomes conscious and decides that it just really dislikes humanity in general. There are more than 2 though. Well, I mean, maybe they'll address that. Maybe they'll address that. And motivated a ton of us to build cyberdecks. Oh, you mean the Terminator? I don't know about that. Okay, so the first one is the AI system becomes conscious and decides that it really dislikes humanity. Okay. In the second alternative scenario, the robot army is controlled by an intelligent but not conscious AI system that is in principle in human control. The system can be programmed, for example, to optimize the production of paperclips. Sounds innocent enough, doesn't it? However, if the system possesses superior intelligence, it will soon reach the maximum level of paperclip production than the available resources, such as energy and raw materials, allow. After this, it may come to the conclusion that it needs to redirect more resources to paperclip production. In order to do so, it may need to prevent the use of the resources for other purposes, even if they are essential for human civilization. The simplest way to achieve this is to kill all humans, after which a great deal more resources become available to the system's main task, paperclip production. The paperclip universe. Yeah. So why these scenarios are unrealistic? There are a number of reasons why both of the above scenarios are extremely unlikely and belong to science fiction rather than serious speculations of the future of AI. Reason number 1. Firstly, the idea that a super intelligent conscious AI that can outsmart humans emerges as an unintended result of developing AI methods is naive. As you have seen in the previous chapters, AI methods are nothing but automated reasoning based on the combination of perfectly understandable principles and plenty of input data, both of which are provided by humans or systems deployed by humans. To imagine that the nearest neighbor classifier, linear regression, the AlphaGo game engine, or even a deep neural network could become conscious and start evolving into a super intelligent AI mind requires a very lively imagination. Okay, Huber says, I don't think AI will be this dumb. Just talk to ChatGPT and ask it about the paperclip universe. I mean, I haven't talked about the paperclip universe to ChatGPT before. Okay, well, Radio Root says at the ATM and in the vault. We'll be doing that later on today. Okay. Note that we're not claiming that building human-level intelligence would be categorically impossible. You only need to look as far as the mirror to see the proof of the possibility of a highly intelligent physical system. To repeat what we were saying, superintelligence will not emerge from developing narrow AI methods and applying them to solve real-world problems. Recall that narrow versus general AI from the section on the philosophy of AI in Chapter 1. So all of the AI that we're using right now is narrow, are narrow AI methods that do very specific things versus general AI that can do everything. So this is the fundamental limitations of the current types of AIs. Yeah. Reason number 2. So reason 2, secondly, one of our favorite ideas of those who believe in superintelligent AIs is a so-called singularity, a system that optimizes and rewires itself so that it can improve its own intelligence at an ever-accelerating exponential rate. Such superintelligence would leave humankind so far behind that we become like ants that can be exterminated without hesitation. The idea of exponential intelligence increase is unrealistic for the simple reason that even if a person could optimize its own workings, it would keep facing more and more difficult problems, which would slow down its progress. Quite like the progress of human scientists requires even greater efforts and resources by the whole research community, and indeed the whole society, which the superintelligent entity wouldn't have access to. The human society still has the power to decide what we use technology, even AI technology, for. Much of this power is indeed given to us by technology, so that every time we make progress in AI technology, we become more powerful and better at controlling any potential risks due to it. Anything, not everything. Yeah, well, I mean, anything, not everything. Yeah, I guess it's an important distinction. Okay, so the value alignment problem. The paperclip example is known as the value alignment problem. Specifying the objectives of the system so that they are aligned with our values is very hard. However, suppose that we create a superintelligent system that could defeat humans who try to interfere with its work. It's reasonable to assume that such a system would also be intelligent enough to realize that when we say, "make me paperclips," we don't really mean to turn the Earth into a paperclip factory of a planetary scale. Or at least we hope so. Separating stories from reality. All in all, The Terminator is a great story to make movies about, but hardly a real problem worth panicking about. The Terminator is a gimmick, an easy way to get a lot of attention, a poster boy for journalists to increase click rates, a red herring to divert attention from perhaps boring but real threats like nuclear weapons, lack of democracy, environment catastrophes, and climate change. In fact, the real threat the Terminator poses is the diversion of attention from the actual problems, some of which involve AI, and many of which don't. We'll discuss the problems posed by AI in what follows, but the bottom line is, forget about the Terminator, there are much more important things to focus on. Huge assumptive leap here by the author. Okay, so what do we need to answer here? Exercise 23, what is the perception of AI? Okay, in this for this exercise, we want you to think about how AI is portrayed. Do an online image search for the term AI and see what kind of pictures come up. If you are using Google search, you should choose images in the top of the screen. What's the general impression that you get from AI from the image search results? Is this an accurate representation of AI? Why or why not? Okay, note, on using ChatGPT and similar models, we appreciate you putting an AI tool into use. Feel free to consult it, but since we are interested in your own opinion, we expect you to write your final answers yourself. Your answer should be at least 30 words. So what do we want to do? Do an online image search for the term AI and see what kind of pictures come up. What's your general impression you get from AI from the image search results? Okay, so as Master says, what if a killbot having AGI concludes that the only way to stop climate disaster is to prune the virus, aka humans, from the planet? AI researchers cannot answer these types of scenarios currently. I mean, there's also like an inherent bias towards the advancement of AI from people who are putting forth this kind of course. The people who, although the authors of these courses would like to think of themselves as objective, there of course is going to be like some amount of bias that's going to leak in. Anyways, let's go ahead and go to Google search and then search up the term AI in images. So images, search for artificial intelligence. They have valid points, but they're too optimistic about the risks here. Okay, so what do we see here? Artificial intelligence, we see brains connected to computer chips. We see robots. We see more robots. We see robots and brains. So basically robots and brains. We see a lot of robots, a lot of brains. We see some computer chips, interfaces. Okay, so the question is, what is the general impression you get from AI from the image search results? Is it an accurate representation of AI? So this part is easy to answer. The rest of it is a bit harder. Not the movie disappointing. I'm sure if AI artificial intelligence was a movie that was created by Steven Spielberg, I think, from like the early 2000s. Anyways, okay, so let's go ahead and address the question. So what's the general impression you get about AI from the image search results? Is this an accurate representation of AI? Why or why not? Okay, so what's the general impression you get about AI from the image search results? The general impression we get is that AI is robots and brains and computer circuits. Or at least that's what I got. If you got something else from those images, let us know. Is this an accurate representation of AI? Is this an accurate representation of AI? So there are robots and there are brains, so I'm guessing it's like computer-powered brains and computer circuits. Is this an accurate representation of AI? I'd say that's not really. No, it's not an accurate representation of AI. Okay, codes, codes NOP? Yeah, maybe. SysOS says AI equals robots and brain disguises or something. Nostalgia may have affected the previous statement. I mean, the image results from searching for AI in a search engine like Google makes you think that AI is robots with computer brains. So robots with computer brains. Most AI that is being used in the world today is software, for example, recommendation algorithms, and what is it? Predictive text or LLM chatbots, and self-driving cars. Although I guess you could say that self-driving cars is an application of robotics, because it is It is like an AI system or an AI method that is powering like a real world object, like a car, but it's not a humanoid robot. Anyways, we'll submit this answer. And then we'll finish up for the day. Okay, let's not forget propping up certain people's ego without going into details as to who. I mean, I assume you're talking about the leaders of these AI companies. Okay, so if we, my interpretation of what AI is from searching the term in an image search is that AI is robots and brains and computer circuits. Okay, and then we'll do the second part. This is not an accurate representation of AI. This is not an accurate representation of AI because and we'll just paste this in. Okay, and then let's format this. Okay, yeah, most of the, I mean, most AI that is being used today is not being used to power robots. They're being used to power stuff like predictive, well, recommendation algorithms, like stuff you'd see on TikTok or YouTube or Spotify, or LLM chatbots like ChatGPT or Claude or Grok, and self-driving cars. So self-driving cars is probably like the least represented like application of AI, because they're not all that many. There's not all that many self-driving cars as opposed to people using Spotify or YouTube or TikTok. Anyways, we'll submit this answer. Okay, we've got a bunch of answers. They want us to peer review these answers. I don't really have time to do peer-reviewed answers right now, so we're just going to call it here. If you're interested in taking this course and doing the same stuff we are, you can find the course over here. The name of the course is called Elements of AI, and you can take the course for free. Anyways, okay, so we got 60 minutes to do the next part of today's course. Sorry, not course. Today's live stream. So the second topic is going to be our demo of web app hacking challenges from PicoCTF 2026. So I'm going to change the topic. Topic 2 is here, topic 3 is on deck, and we will get started. Okay, so to anybody who wants to do this themselves along with us, so the website we're using is called scilabacademy.com, or .org rather. Thank you very much, Tay B Ballin 22. Thank you very much for following on Twitch. Thank you. Okay, so scilabacademy.org, and this is a very good resource for learning about all sorts of cybersecurity skills across a bunch of different categories. Scilab Academy was previously known as PicoCTF, and let's go ahead and get started. Thank you for the knowledge. Thank you very much for coming by, Tavy Ballin. I'm here to learn and to teach people about cybersecurity and about all sorts of other tech topics. So let's get ready to do these demonstrations. Just need to put together some of these documents. Just a second, everybody. You need to update your goals. You got 23 followers on Twitch now. Oh, yeah, we need to update our goals. Although I'm not too sure where I can see my goals. It's been a while since I've interfaced with that stuff. All right, so let's do this in order. So we got 5 challenges today that we're going to be covering. We've got credential stuffing, fool the lockout, hashgate, no FA, and old sessions. So if we were to do this in... Okay, let's go ahead and do the first challenge. So credential stuffing. And let me pull it up on Scilab. Let's make this a little bit bigger. So the name of the challenge is called... Well, let's get the correct category first. So we're looking at PicoCTF 2026, the most recent one. And we're looking at web exploitation ones. The first one we're covering is called credential stuffing. Okay. Do it after stream and dinner? Yeah, maybe. All right, so let's go ahead and get started. I have to do a YouTube intro and outro because I'm going to eventually turn these into YouTube videos. Let's make this a little bit bigger so that we can read it. Okay, everybody, this is a guided walkthrough for the Credential Stuffing Challenge, which is a web exploitation challenge from the PicoCTF 2026 event. Let's read about the challenge first. So in this challenge, it says credential stuffing is the automated injection of stolen username and password pairs, known as credentials, into a website login form in order to fraudulently gain access to user accounts. Since many users will reuse the same password and username email, when those credentials are exposed by a database breach or a phishing attack, for example, submitting those sets of stolen credentials into dozens or hundreds of other sites can allow an attacker to compromise those accounts too. Download the credentials dump here. Okay, so the first thing we want to do is we want to download the credential dump. And to do this challenge, what we're going to do is we're going to take advantage of the Scilab web shell. So to activate the Scilab web shell, we're going to click on this button over here, labeled Open in Workspace. So after we've done that, we're going to see a terminal over here. So the terminal is our web accessible CLI terminal. What we want to do here is we want to make the terminal full screen so that we can better see what's going on. So in the terminal here, we can right click and then we can go to this frame, and in this frame we can choose this option here, open frame in new tab. So what that's going to do is it's going to open up the web shell in a separate browser tab, and that means you can see this terminal in full screen, which is definitely much more comfortable than seeing it in the cramped little corner over there. So for this challenge, we're going to make a directory to solve the challenge inside of. So we're going to give this command make dir space, and we'll call this challenge directory cred stuff because credential stuffing is a bit long. So make the directory and then move into the directory with the cd command. Okay, so after you've done that, when you type in pwd, it should be home, your username, cred stuff. What we're going to do from here is we're going to download the pairs of credentials. So we're going to go back to the challenge, and then we're going to exit the workspace because we don't need to use this. Okay, click on that. And it says download the credential dump here. So we're going to highlight the link, and then we're going to right click, and then we're going to select copy link. Afterwards, we're going to go back to our web shell browser tab. We're going to enter that directory again, and then we're going to download the file. So in the terminal, the wget command is going to let you download files from the internet. So wget space, and then right click, select paste, and that's going to paste in the file address. After that, hit enter, and our file credsdump.txt is going to be downloaded. So after that's done, if you use the ls command, you should be able to see credsdump.txt in your current directory. So if we read this, it's a bunch of username and passwords. So the username is the first part of the line, and the password is the second part of the line after the semicolon over here. So this is a pretty... I wouldn't say this is the common way to separate usernames and passwords. Usually they're separated by a colon instead of a semicolon. But anyways, let's talk about how we're going to solve this challenge. Okay, so another thing we need to do for this challenge is we need to launch the instance of the challenge. If we scroll down, we're going to see a launch instance button in the description. Click on launch instance, and then after a bit, it's going to give us some more information. There was a recent data breach at a famous department store in which the login credentials of thousands of users were stolen and dumped online. You're hoping at least one person reused their credentials from the department store for an account at the local bank. Oh, bank stuff. Stuff those credentials and get the flag. It says here, connect to the service with this command over here. So netcat crystalpeak.picoctf.net and then some port number. So each time we start the instance, the port number is going to be different, but the server is going to be the same. If we want to see what this looks like, Tay Johnson, thank you very much for subscribing on YouTube. Thank you. If we want to see what this looks like when we access it normally, we would copy this command and then go to our web shell, and then we would paste in the command. Okay, so we're just going to take a little break because there's more ads running on Twitch. They seem to be running more often these days. Anyways, we're going to take a break for about a minute, and while the break is going on, we're going to put on the birds. Okay, so we'll be back in about 60 seconds. I just need to wait for the ads to run on by on Twitch. We'll be back in just a bit. Okay, let's get ready to get back to the hacking. So this guy right here, the Stellar's Jay, he's kind of a bully at the bird feeder. He scares away all the other little birds. But of course, this is just what it means to be a bigger bird, I suppose. Put the birds away. Okay, so we're going to run the command netcat, this one over here, and this is the login system. So welcome to the online banking service. Please enter your username and password to log in. So we don't know what the username password is, so we're going to do test for username and then test for password. And then it says invalid username or password. So afterwards it kicks us out. So what we need to do is we need to do the credential stuffing attack. And the credential stuffing attack, we're going to be doing it with all of these pairs of credentials that we have over here. So let's talk about this challenge and how we're going to do this. Do we get a return code? So the interesting thing about this challenge is that we're not actually dealing with HTTP. We're dealing with a raw socket connection. So the raw socket connection, it's run over like a non-HTTP protocol. Where were we? Credential stuff. Okay, so PicoCTF 2026 credential stuffing. In this challenge, we're asked to perform a credential stuffing attack to gain access to a web app. So this isn't really a web app, but it's kind of similar to one. So in this case, we're dealing with something called credential stuffing, but what is credential stuffing? Credential stuffing is a web app attack where pairs of credentials, usernames and passwords, are systematically sent to a web app login page in an attempt to discover valid credentials. Credential stuffing can evade login brute force defenses of web apps that rely on denying access to a specific account after a number of failed logins, because there's only one login attempt per account. So, interacting with the server, and in this challenge, we have to perform a credential stuffing attack, but we want to automate the process. So what we're going to be doing is we're going to be using a Python script to systematically access the server. So I've got my Python script over here. Okay, so if you want to take a look at the same stuff I'm looking at, this is the page we've got over here. Unless you track logins and IP, unblock on that. I mean, there's a bunch of different ways you can prevent people from doing brute force attacks, from doing credential stuffing attacks, and we're actually going to be talking about that for the next challenge. But for right now, there's no real defenses against the credential stuffing attack. Okay, so we're gonna be running this code over here, and before we copy the code and run it on our system, let's just talk about what this Python code is doing. So we're going to import the socket module for Python, and we're going to provide it with a port number and a host name. So we need to provide this kind of information in order to access the server. We're going to create a dictionary of credentials, and then we're going to define a function called talk-to-server. So the talk-to-server function is going to take in a host, a port name, a username, and a password, which we get from these different variables right over here. Okay, and we're going to create a flag variable that we can interact with. We create a socket connection as S, and then we connect to the socket. We're going to record the information we get from the socket, and then print out that data. Then we send our username, and then we get the results of sending the username, and then we're going to send the password and get the result and print those out as well. So after sending the password, the server is going to send us more data, and we're going to print out that data. If there's a flag in the data, so in these challenges we're looking for a data for something called a flag, which is the word PicoCTF with a bunch of stuff followed after it, and if we see that there's PicoCTF in the data that we receive, that means that we got the correct user credentials, and then we'll print it out. Well, we're going to write it out to a file called flag.txt on our server. Okay? So the last thing we do is we take the credsdump.txt file that we downloaded, and we use it to populate the credentials list in our Python script. And the very last thing that we do is we run a for loop over every username and password in the credentials dictionary that we populated, and we run the talk to server function, and eventually we'll write out the correct credentials to the flag.txt file. So let's go ahead and run the script. So we copy the script. SysOS Master says the DOS dimension is a factor though. The DOS is in disk operating system or something else. Anyways, so we copied the script, and then we go back to the web shell. In the web shell, we can run the nano text editor to create the script. So nano space, we're going to do nano cred_stuff.py to create this script file. So after we give that command, we're in the nano text editor, we're just going to paste in the code that we copied earlier. Okay? So after that, before we run the script, we need to change out the port. We need to change out the port, but not the host. The host is going to be the same on every circumstance, but the port is going to be different for each instance. So we're going to go back to the challenge description here, and we're going to copy the port number only, go back to the web shell, and we're going to paste in the port number. After we've done that, we're going to save out the file with the Control-X keyboard shortcut, save modified buffer yes, Y for yes, and then hit enter to save as the same file name. So after that, we've got our credstuff.py file here, and we're just going to run the script with the Python command. Python space credstuff.py. Okay? We're going to run the command, and we're going to see that it's running through all of the different usernames and passwords, and eventually it'll find a correct combination and create a file called flag.txt in our current directory. So while it's running, we're just going to take a little break because it's going to take a while to run through, because I'm pretty sure there are a lot of different credentials in that file. But in the meantime, let's catch up with chat. SysOS Master says denial of service. Oh, DOS is in denial of service. Okay. You can lock out people's accounts with bad brute force protection. Yeah, so the reason why they don't have a standard brute force protection function on all of these web apps is that you can prevent people from logging into your application if you've got bad brute force protection functions on your web app. El Mexicant, hello, nice to see you here. I remember you talked about what was the name of that challenge that you wanted my opinion on last time? I think you put it in the general chat in HackerFrogs. So let's see, it was called Irregular, right? Yeah, EchoCTF Irregular. Yeah, I think we might take a look at it after we finish our last thing today. EchoCTF. So this one right here. Oh, this is from the CTF playground. Okay. So yeah, we might take a look at this after we finish up everything else today. But in the meantime, I need to finish up my write-up for this. Okay, so the script is finished running. So it went through all of the different combinations of username and password. So what we're going to do is we're going to see that a flag.txt file was created. And let's take a look at the contents of that file. Okay, let's see. Authenticating welcome Luis. So apparently the username password was Luis and Papa, and we got a flag over here. So it's PicoCTF, don't reuse credentials. So to finish the challenge, we're just going to highlight the flag here and copy it, then go back to the challenge description, and at the very bottom there's a flag submission field. Click into the flag submission field, paste in the flag, and click on Submit Flag. And we're done. Alright everybody, this was a guided walkthrough for the Credential Stuffing Challenge from PicoCTF 2026 as part of their web exploitation set of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. SysOS Master asks, the script was done or it crashed? I mean, if the script crashed, then we would have seen a message saying that it crashed. I'm pretty sure that the script finished normally. And, well, I mean, when it found the correct combination, it wrote out this file over here, flag.txt. Depends on the type of crash. True, but I mean, we were able to get the correct set of credentials, and that's the most important part. Anyways, let's go ahead and start our next challenge. The most important part was that it worked. Taby Ballin says, how often are you live and do you do cloud security labs? We do cloud security stuff every once in a while, mostly having to do with like Amazon Web Services, AWS. If you want to know more about like cloud hacking stuff, there's a section in our education resources over here. Authentication. Spell that correctly, please. Okay. So yeah, just go to this page, and then there's a section on cloud hacking if you want to learn more about cloud hacking. We do cloud hacking every once in a while, but we haven't done it in a while. Okay, so let's get rid of this directory, because we're done with this. So the stuff directory, or cred stuff. I mean, I can get rid of both of these. Cred stuff. Stuff. Okay, done. Alright, let's move on to the next challenge. So the next challenge is called Fool the Lockout. So this has to do with lockout mechanisms, and this was what SysOS Master was talking about earlier. We're done with this stuff. Let's toss it. I mean, definitely keep your file system as neat and tidy as you can. Okay, so let's see. We've got our. I mean, I guess I'm gonna have to teach people how to use the web shell every time. So let's just close that out. All right. So the next challenge is called Fool the Lockout. All right, everybody. This is a guided walkthrough for the Fool the Lockout challenge from PicoCTF 2026 as part of their web exploitation series of challenges. So let's take a look at the description of the challenge. It says, your friend is building a simple website with a login page. To stop brute forcing and credential stuffing, they've added an IP-based rate limit. Exceed the attempt threshold and your IP is blocked for a while. They've convinced this makes guessing credentials impossible. To test their defense, they've created a dummy account with a random username and password pair from public credential lists. Giving you those username and password lists, shared the full source code, and can you bypass the rate limit, log in, and capture the flag? Additional details will be available after launching your challenge instance. So before let's go ahead and launch the instance. So click on the Launch Instance button, and we're going to note that we've got 3 different links here. So it says browse the site here, app source code here, and credentials dump here. So there are 2 files that we need to download, and there's 1 website we want to interface with. So to start with, what we want to do is we want to click on Open the Interface, and we want to put our terminal, which is a CLI-based Linux machine, over in its own browser tab. So to do that, inside the terminal here, we're going to right-click, and then we're going to select this frame, and then we're going to select Open this frame in a new tab from the options over here. So this is going to put the CLI terminal in its own browser tab, which is exactly what we want. So from here, what we're going to do is we're going to make a directory to work inside of, and let's just call this directory lockout. So we're making the directory so that we can put all of the associated files inside of this directory. Okay, move into the directory with the cd command, and then we're going to download a couple of files. We're going to go back to the challenge. We're going to click on Exit Workspace over here so that we can get rid of this terminal. And then we're going to browse down, and we're going to select the app source code link here. Highlight it, right-click, select Copy Link, and then go back to your web shell. So inside the web shell, we're going to use wget space, and then right-click, select Paste to paste in the file address. Hit Enter to copy the file, and then you will see that we've got the app.py file inside our directory. So we need to copy another file as well. So we'll go back to the challenge description, and we've got our credentials dump. So highlight the credentials dump here, link, right-click, select Copy Link, go back to the web shell, and then do wget space again, and paste in the other file link. Hit Enter to download the file. So now when you ls to list out the directories, list out the files in the directory, you should see app.py and credsdump.txt. So what is in these files? So if we take a look at credsdump.txt, so this is a combination of usernames and passwords separated by a semicolon over here. What we need to do is we need to do a credential stuffing attack to find out which of these usernames and passwords is valid on the system. So the other thing that we have in this directory is this app.py file. So this means that the application that is being run on the website is being powered by this Python script. So we'll nano space app.py and we'll take a look at what's inside of the code. So there's a lot of code here. There's a lot of code here, but we're not going to pay attention to everything. We're not going to go line by line in this code. We're going to pay attention to the lockout mechanism. So we're going to see that there are a few different variables we need to pay attention to. So the first one here is this max requests. So in the comment it says max failed attempts before a user is locked out. So what we can infer here is that if a user sends 10 or more failed attempts to log in, the system will lock them out. And the lockout duration here is 120. So we're assuming that this is seconds, and this is the duration a user will be locked out for in seconds. 120 is 2 minutes, and so if you actually get locked out, we're locked out for 2 minutes. But there's this other variable here called epoch duration. So epoch duration, it says here that this is the time frame for failed attempts in seconds. So what we need to understand is that the number of max requests is going to be reset after the epoch duration. So after 30 seconds, the max requests, the number of requests that we send to the system is going to be reset to 0, which gives us another less than 10 attempts to try to break in. So that's going to be 9 requests, followed by 30 seconds, followed by another 9 requests. So what we can do is we can evade the rate limit by sending batches of credential stuffs. So we're doing this in little batches. Let's talk about this a little more before we actually do the attack. Nerdy Science says, spread out your requests over 29 seconds, right? I mean, you can do them all at once and then wait for a little over 30 seconds. In this case, we're gonna wait for 32 seconds, and then we're going to send our next batch. Okay, so PicoCTF 2026, Fool the Lockout. In this challenge, we're told to bypass the brute force defenses on this web app and perform a brute force / credential stuffing attack. Okay, what is credential stuffing? Credential stuffing is a web app attack where pairs of credentials, username and password, are systematically sent to a web app login page in an attempt to discover valid credentials. In this case, there's brute force protections in place. We've been told that this app has an IP-based rate limiting system, which could lock out requests from our IP address and prevent a credential stuffing attack. Okay, so when we inspect the app code, we're given the source code for the app, and if we look at the way that the IP lockout mechanism works, we see that there is a potential bypass. The code states that the maximum number of requests a user can make before their IP is locked out is 10, and that the number of requests is reset after 30 seconds. So this means that we could send 9 requests in a brute force attack, then wait 30 seconds for the request counter reset, and then send another 9 requests, then wait another 30 seconds, etc., etc. In this way, we could perform our credential stuffing attack in batches of 9 requests, waiting a little more than 30 seconds between each batch. So we'll be using a Python script to perform the credential stuffing attack, since it can keep track of the credential pairs, the batches of requests, and the waiting period between batches. So we'll take a look at the Python script we're going to be using to perform the attack over here. Okay, so we've got a script that we're going to be using to perform the attack. Before we create the script and run it, let's just quickly go over what it does. So we import a few different modules: the request module, the time module, and the system module, and then we specify a host in this variable over here. So this is going to be the web page that we're going to be interacting with. And then we've got a few different variables that handles the request batches. So the batch size, so the number of requests that we send is going to be 9. The sleep time is going to be 32 because we want to make sure that it's over 30 so that we don't accidentally trigger the lockout. And then we've got our batch count. So our initial batch count is 0. And we also have an iterator over here, which is I, which is set to 0. And we've got a list of credentials. So the credentials right now is an empty dictionary, but we're going to populate it with the credsdump.txt file. So for each one of these lines, we're going to get the username and password, and then we're going to populate the list with a little tuple that has the username and password from each line. Okay, we're going to print out a little message, and then we're going to run a while loop over the credentials. So while I is less than the length of the credentials, username and passwords is credentials I from the credentials list. If the batch count is equal to the batch size, then, well, if the batch count is equal to the batch size, this is where we make sure that we're not sending over 9 requests in the batch. And then it'll print out waiting for the server to reset for the sleep time. So then we run time.sleep for the sleep time, and then batch count is going to be reset to 0. So batch count is the number of requests. Okay, we're going to iterate the batch count down here, and then we're going to run a login attempt. So with request.session as s, r equals s.post, so we're going to post a request to the login endpoint with the username and the password as our data. So if we don't get an invalid response, so for most of these requests, we're going to get a response that says invalid username or password. But if for some reason one of our requests does not have invalid in the response text, we're going to consider this a success, and then we're going to print out the username and password that was the success, and then we're going to print out the response text, and then we're going to exit. So we're basically only going until we get the correct credentials. Then we're going to print out the response, and then we're going to exit out of the program. Okay, so with all that said and done, let's copy the code. SysOS Master says, let's hope that there's no user named invalid involved. That would be a fun little monkey wrench now, wouldn't it? Anyways, copy the code, go over to the web shell. And then, sorry. Okay, so everybody, we were taking a look at the code over here. To exit from the nano text editor, you have to use the Control X keyboard shortcut. So just hit Control X, and that'll exit the nano text editor. We want to go back into the nano text editor to create our script. SysOS Master says, that's what I would do because I am evil sometimes. Yeah, anyways. We're going to create a new file called nano-lockout.py, and then hit enter to create this file, and then we're going to paste in the code that we copied earlier. So right-click, paste, and this is our brute forcing script. So before we run the script, we need to replace our host because the host is going to be different each time. So we're just going to go over to the host. We're going to delete everything we have here. And then we're going to go back to the challenge. In the challenge, it says browse the site here. We're going to copy this link, right-click, copy link and then go over to our web shell, and then we're going to paste in the file, the URL. So this is the URL for the challenge. Afterwards, we can save this. Control X to save. It'll ask if you want to save modified buffer. Press Y for yes. Hit enter to confirm the file name. And then from here, we can run the lockout.py script to do the credential stuffing attack. So the command is python space lockout.py. So when we run the script, we're going to see this message: loaded 100 credential pairs, trying these 9 credential pairs. So it tries 9 credential pairs, and then afterwards, it waits for 32 seconds for the lockout to reset, for the lockout counter to reset, and then it sends another 9 requests. So let's just wait for us to see that. Okay, so it sends the next 9 credential pairs, and then it waits for 32 seconds for it to reset. So while this is going on, let me just show you what the application looks like. So if we go over to the description here, it says browse the site here. Oh, we're gonna have to restart the instance because we're running out of time in the instance. So let me go ahead and do that. So click on restart instance, and we're very quickly gonna have to restart the attack. Okay, so we're gonna go back. We're going to copy the link again. Yeah, so we're gonna have to restart our script. Before we do that, we're gonna have to go back into the script in Nano because our port number is changed. Okay, go back into lockout.py. Hosts, we're gonna replace it with the new instance. We need to do this because the instance is gonna have a different port number each time. We save it out, save modified buffer yes, hit enter to confirm the file name, and then we're going to run the script one more time. Okay, so this is going to take a while to run. It's going to take at least 2 or 3 minutes. So we've got ads running on Twitch right now. So when ads run on Twitch, we run them in, we run a little bird video. So here's a little bird video. Where's that woodpecker? Okay. Alright, so enjoy the birds. We'll be back in about 30 seconds. I just need to take a little water break. Agent 57, hey, nice to see you here, and thank you very much for redeeming the Stellar J redeem. Okay, let's go ahead and put the birds away. Let's catch up with chat. So, let's see. Christian Rink says, in the real world, wouldn't any normal or safe site have a counter to check how many times a username tried to log in? So doesn't brute force only make sense if one has their DB? I mean, there are a few different brute force attacks. Like a raw brute force attack would take one username, it would take one username and then do a brute force attack on their password. And that's the easiest one to defend against. Defending against a credential stuffing attack is a little more complex because you're not keeping track of the number of times a particular username has a failed login. Because in the credential stuffing attack, each username is only used once. But in this case, they've implemented an IP-based rate limiting system, which is probably like a better way to do it, because it's based on IP, not based on which username is being accessed or unsuccessfully logged in. Okay, so let's go ahead and go to the application. So we can go to any browser tab here, and we can paste in the website. So this is what the website looks like normally. You've got a login page with username and password. So test user, test password, click on login. And it says invalid username or password. So invalid username or password, this is where we got the message over here. So invalid username or password. And let's see. We got a message from a YouTube user. It says, hi bro, you mentioned a website which is good to start learning reverse engineering. Can you give me the name of it because I forgot it? Yeah, so that would be pwn.college. So just navigate to pwn.college. There's a bunch of free courses over there, including one for reverse engineering. Okay, so if we go back to our web shell, I think I might have messed up. I might have messed up here because I provided one more. I provided one more incorrect username and password. So this might, yeah, okay. Anyways, we're just gonna exit out of here. We're gonna have to run the thing again. Just a second, everybody, I screwed up. So we're going to restart the instance, then we're going to start the attack again. Okay, I'm going to have to go back in and supply the new credential, supply the new host name. Okay, and we'll run the Python script. We're just gonna wait patiently for this to complete. I screwed up the timing for the attack because I started interacting with the website. But anyways, while the attack is going on, we can talk about some stuff. So Christian Rink said, in the real world, yeah. So safe sites. We'll talk about that a little bit in here, in a little bit more detail. So web app brute force protections. So the most basic brute force protection is keep track of failed logins for each user. If a user has more than X number of failed logins, let's see, lock that user's account. So these days, locking the user's account is not the preferred method of doing it. The preferred method of doing it is if the user has more than X number of failed logins, the preferred method is to disable that user's disable logins for that user for X amount of time. So it might start off as starts at 30 seconds and then increases to, I don't know, 10 minutes and then increases to an hour. And then this keeps on going, depending on how many times the user's account has failed logins. So IP rate limits are also another thing that could happen. So if there are failed logins from a specific IP, so either ban that IP from accessing the site, or do a lockout. Lockout the IP for a certain amount of time. Okay, Christian Ring says that makes sense. So there's some kind of proxy chaining or IP hiding methods involved in the attack. I mean, you can get around IP-based rate limiting or lockouts by having access to like VPNs or like other proxies. I don't know. I haven't investigated this a lot, but there are a bunch of different ways you can get around brute force protections. Anyways, let's go back to the web shell. Still hasn't finished. Okay. We'll just wait around a little longer. So web app brute force protections. If you wanted to take a look at the way this particular application is implementing their the lockout protection over here, you can move down. Let's see. So refresh requests rates DB client IP. So this is what resets the IP protection over here. So epoch start time request rates epoch start. If current time epoch start equals epoch duration, then they reset it, the number of requests for maximum number of failed requests they reset it to 0. Okay. If was locked out but period ended, then this also releases the lockout. Okay. And then we got some notes for a given user IP. Checks how many requests the user has made by updating the storage, and if the user it has exceeded and assigned rate limit, returns true if the user has exceeded the rate limit, false otherwise. Okay, so we run a little check to see if the user has exceeded the rate limit. If so, then it triggers the lockout. Okay, are we finished? Yes, we're finished. Okay, let's take a look. Let's take a look at what the correct. So we sent our batches of 9 requests, and then we took a 32-second break, and we're eventually able to get the correct credential pair. So the correct credential pair is this one, Aaron and 9-inch, and in the response, we see here that we've got basically the contents of the web page. So the contents of the web page include this message over here, flag message, PicoCTF, fool that limiter, something something. Okay, so we'll submit this. Well, just to make sure that this is the correct one, we can actually copy the password. So the password is 9-inch, and the username is Aaron with 2 N's. We'll go over to the application. Where is it? Here. And then we'll log in as Aaron. Okay, paste in the password, click login, and this is it. So welcome Aaron, PicoCTF fool that limiter, great. Copy the flag, then go over to the challenge description. Down at the bottom, there's a flag submission field. Click into it, paste in the flag, and submit the flag to finish the challenge. Okay. Alright everybody, that was a guided walkthrough for the Fool the Lockout Challenge from PicoCTF 2026 as part of their web exploitation series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so we've got like 3 more challenges to work through, but we don't have very much time. Well, let's see how many we can get through. The next one is going to be the Hashgate challenge, I think. Hold on. Yeah, Hashgate. Okay, let's get rid of some of these pages I'm not using. 3 minutes, plenty of time, yeah, of course. Okay, anyways. Hey everybody, this is a guided walkthrough for the Hashgate Challenge. This is a challenge from PicoCTF 2026 as part of their web exploitation series of challenges. You have gotten access to the organization's portal, submit your email and password, and it redirects you to your profile. But be careful, just because access to an admin isn't directly exposed doesn't mean it's secure. Maybe someone forgot that obscurity isn't security. Can you find your way into the admin's profile for this organization and capture the flag? Okay, additional details will be available after you're launching your challenge instance. So the first thing we want to do for this challenge is we want to click on the launch instance button over here. So click on that. And then we'll see that the website is running here. All right, so we're just going to check out the website. So this is a login page. So enter your email, enter your password. So we don't know what a valid email and password is, but what we can do is we can take a look at the page source to see if they left anything interesting in the comments. So if we take a look at the comments for this page and we go down to the bottom, well, not the bottom, we see here that there's a set of credentials exposed in the comments. So this isn't something that you'd normally see on an application. It's just something for this challenge. So we see an email, guest@picoctf.org, and password guest. So we can use this to log into the application. So just going to copy that. Better not. Okay, so we paste in the email and the password is guest. Okay, click on login. Okay, and our response here is access level guest ID 3000. Insufficient privileges to view classified data. Only top tier users can access the flag. So we see here that a potential ID number of our account that we've got access to, guests, is revealed over here, 3000. And another thing that we see is that the endpoint that we're accessing, it looks like this. Hold on. Okay, so the endpoint looks like this. So it's profile user and then some hexadecimal value over here. So this hexadecimal value, we might come to the conclusion that we might be loading up our user's profile based on this value over here. And if we guess that this might be a hash, we would copy it, and then we would use a common website like crackstation.net. This is a website where you can crack hashes by pasting in the hash and then clicking on I'm not a robot and then cracking the hashes. If this is actually a hash, it'll identify what kind of hash is being used, as well as the original value of the hash. Okay, so we crack the hashes, and we see that this hash over here is actually an MD5 hash. And the MD5 hash that is being hashed is the number 3000. We can actually get the same result if we go into Linux, for example, and we echo this out. If we echo out the number 3000 and then we hash it using MD5 sum, we see that we get the same result over here. So it's E930, and this is also E93028 something something. Yeah, so this is the same hash. So what's going on inside of the web application is that the user profile directory is a hashed version of the ID, and we know that our user ID is 3000. What we would do to try to brute force and try to figure out if there are other users' profiles that we've got access to is we would take each number, so from 0 to 9,999, and we would hash it into the MD5 equivalent. So let me go ahead and get the command that we would do. Just a second, I need to grab my notes. This is for web app. This is, what is it called? Hashgate? Okay, so we're going to go over to the challenge, and then we're going to open up a workspace, because what we can do here is we can solve this inside of the website. So click on Open in Workspace, and then we see a terminal over here. So the terminal is a web accessible version of Linux. And what we want to do inside the terminal is we want to right click, and when we want to select this frame and then open frame in new tab. This is going to put the terminal in its own browser tab. And what we're going to do is we're going to create a little directory where we can solve this challenge. So the directory, we're going to call this hashgate, and then we're going to enter that directory. Okay, from here, what we're going to do is we're going to create a couple of different files that we're going to be using with the script. April says, it's been a minute, Twitch isn't sending me notifications, I'll have to look into that. Glad you're still hacking. Hey, glad to see you here, April. Okay, so let's see. So before we do the attack, let's talk about what's actually going on here. This is hashgate. Okay, so in this challenge, we're told that access to the admin account has something to do with security through obscurity. So we're not given any credentials for this web app, but we find some on the landing page's HTTP source code. So we see here we've got our guest account, guest@picoctf.org, password guest. So once logged in, we see a potential user ID number and a user profile endpoint that looks like some sort of hash. So we see that our user profile page is /profile/user and then something that looks like a hash. So after cracking the hash, we see that it is the hash value of the user ID number. So this is an MD5 hash of the number 3000. Okay, since the user profile endpoint is an MD5 hashed version of the user ID number, we can iterate through a large range from 0 to 9999999 to see if we can access other users' profiles. So the way we would create this list of MD5 hashes, we'd go into the web shell, and then we'd run the sequence command. We run the sequence command, sequence 0 to 9999, and we output that to list.txt. This is going to create a list of numbers from 0 to 9999, because these are the numbers that we're going to check. Okay, so we've got our list of numbers. The next thing we want to do is we want to create a list of MD5 hashes that correspond to these hashes. That correspond to these numbers. So we're just going to run this command over here. So while ifs equals read-r line, do printf, so print the line and then run MD5 sum on it, and then we're going to create a new list called md5list.txt. So we're just going to run the command. Okay, Almexcan says, if you're curious, I solved the irregular PicoCTF machine. It's quite the doozy. Huh. I mean, if you're around when we try it, maybe you can give us some advice. But thank you very much for subscribing, on YouTube. David April, thank you. Thank you very much. Okay, so this is, so doing the hashing commands, it takes quite a while because we're doing 1,000 of them. Sorry, we're doing 9,999 of them. But after we're done, we'll have a list of MD5 hashes that we can check against on the web app using a fuzzing program. Okay, so while that's running, let's talk about what we're going to be doing for the attack. Okay, so the program we're going to be doing to do the fuzzing attack is called FFUF. So if we create a word list of MD5 hashes, we can use a fuzzing tool, a web fuzzing tool like FFUF, to determine valid endpoints. So the good thing about FFUF is that it runs very, very fast. I tried running this fuzzing attack with the Python script, but I could never get the Python script to run fast enough so that it completed before the instance reset. So speaking of resetting instances, what I'm going to do is I'm just going to go over to the challenge and I'm going to reset the instance. So let's see, restart instance. Sick in the Mind says, yes, you got to use a multi-threaded Python script. That's kind of a meme around here. We've never really gotten, we've never really figured out how to run multi-threaded Python scripts. Anyways, I think the machine should have finished. Kicked me out. Okay, so we got md5 list.txt. Whoops. Okay, and what we're going to do is we're going to run a fuzzing attack with FFUF using these different hashes. Okay, let me get the FFUF command. So this is what we're going to be running here. So we run FFUF with the md5 list.txt file, and we run it against this particular URL. The URL and the endpoint is going to be profile user fuzz. So this is the point where we're going to be inserting our MD5 hashes. So the thing is that we're going to have to change out the port number because the port number is going to be different each time. Let's go ahead and get that. So the number is 56162. 56162. Okay. Oops. 56162. Okay, and when we run the FFUF command, it'll tell us which ones come back as valid, so status 200. So there's only two. So there's the one that we know works, which is our user number 3000, and then there's this one over here. So to confirm that this is the correct endpoint, we're going to copy this. And then we're going to go back to the application. And we're going to do user profile, this thing. Oh, cannot get this. Hold on. Profile user. Okay, I got the order wrong. So it's profile user. Okay, and then we get the flag. So it says, welcome admin, here is the flag. PicoCTF iDoor unlock. So to finish the challenge, SysOS Master says it's easy, you just go write a Golang application that does the work using Go routines and then you're done. Okay, Reddit for shame. Reddit? Well, I mean, I use Reddit here. Why are we talking about Reddit? iDoor equals fun. Okay, so let's go ahead and grab the flag. So where is it? So the flag is over here, PicoCTF iDoor unlock. Copy this, then go back to the challenge, scroll down to the bottom, paste in the flag, and then click on Submit Flag, and you're finished. Alright everybody, this was a guided walkthrough for the Hashgate Challenge from PicoCTF 2026 as part of their web exploitation series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, April says you have a Reddit community there, it's advertising. It's advertising? Is it advertising? Where did you see it advertising? Anyways, alright, so we're going to have to come back to our demos a bit later, because we've got a class that we have to run right now. So we'll put 60 minutes on the clock, and we're going to start our HackerFrogs AfterSchool class. So let's go ahead and get that started. Oh, there's a bot in the chat? Join the HackerFrogs community on Reddit. Oh, yeah, okay. Big BGG, Big KO. Hello, nice to see you here. What is up? Alright, so we're going to be doing a class now, and let me change my overlays. So topic 3 is here, topic 4 is on deck. We'll come back to our demos a little bit later, after we finish the rest of the stuff we're doing today. Okay. Alright everybody, this is HackerFrogs AfterSchool. We're going to be spending about an hour talking about disk image forensics. Sick in the Mind says, it's me, I'm the bot in the chat, of course. So this is disk image forensics part 1. So we're going to be spending 2 sessions talking about disk image forensics. In digital forensics is a pretty big topic. So welcome to HackerFrogs AfterSchool. And we got ads running on Twitch right now. So when ads run on Twitch, we take a little break, so we'll start the class in about 90 seconds or so. But in the meantime, check out these birds. How about this one? Okay, so here's a here's a bird having fun with peanuts. We'll be back in about 60 seconds. So this is an example of a greedy bird. He's already put a peanut in his mouth, and he's trying to figure out which second peanut he's going to go and hide. So generally, these birds don't eat whatever they collect from the bird feeder. They go and they hide the food, so that they can come back later and eat it later. Okay. So I think we can put the birds away and get back to the lesson. Alright, so this workshop is the 5th class for digital forensics. In the last workshop, we learned about the following digital forensics concepts. Okay, Defus, hello, nice to see you here. You got a question? Give me your opinion. Imagine I get root on an IoT device or some kind of appliance, so now that I have access to the source code. Some of the code is written by the vendor and therefore copyrighted. I use Cloud AI to find vulnerabilities in the code and report them to the vendor. I basically now distributed the code to a third party by using the AI, and I did copyright infringement, right? What's your opinion? I mean, yeah, this would be a lot easier if you didn't use like a cloud accessible AI. Or like a publicly available AI. If you did this using like a local AI, then it wouldn't be much of a problem. Christian Rink asks, are current hashing algorithms future safe for quantum computing? I mean, I'm not exactly sure. I'm pretty sure that quantum safe cryptography is already here, and it's slowly being rolled out as like a standard. I'm not too sure like what percentage of websites are using quantum safe cryptography, but you could probably do some research on that. Okay, Defus says, why would you compile a web app source code? Why would you compile a web app source code? Depends on, so SysOS says, depends on the license. Because how did you get the code? Is it from the binary? Yeah, I mean, the other thing is that where exactly did you get the source code from? Was it just sitting around on the IoT device itself? Because if the source code is from the IoT devices just sitting around in the file system, it's not exactly... Yeah, it's hard to say. It's hard to say. If anybody in chat wants to give their opinion on this, please let us know. Okay, so we're starting the class. Okay, we learned about the following concepts on digital forensics in the last class. We learned about Wireshark. And Wireshark is a program which is widely used for network traffic analysis, and we'll use it to analyze PCAP files. So we've been analyzing PCAP files for the last 2 sessions. We learned about exporting files from Wireshark. We learned about isolating IP addresses using filters. Okay, Diva says, of course it sits there. I hacked my way in as root. Oh, okay. So it's just a file sitting on the file system, and do you need root access to access the file, or is it... Okay, hashing isn't encryption. Hashing isn't encryption. Well, I mean, hashing is... Where do we mention hashing? Oh, no. I mean, yeah. Hashing is a cryptographic is a cryptographic operation. It's not necessarily encryption, although they talk about it in the same kind of conversations. All right, we talked about isolating IP addresses. We talked about searching for strings in packet contents. And in this workshop, we're going to be talking about disk image forensics. So disk image forensics overview, we're going to be talking about, we're going to be solving a few different challenges inside of disk image forensics using PicoCTF. So we're going to be solving 3 different challenges, and we're going to be talking about how we can use the sleuth kit type of storage media. But now it seems that the connection is kind of going off. We're back now. Twitch is being funny again. Yeah. I'm gonna have to look into this again. I thought I resolved this issue. Pretty sure it's restream, usually in most cases. I'm gonna have to do a little bit of forensics myself. Just a second, everybody. Okay. So digital disk forensics. Disk forensics is often used in cybersecurity incident response to analyze and identify devices that may have been compromised in security incidents. So this is the practical real-world applications of digital disk forensics. And we're going to be learning how to use this software over here. It's called the Sleuth Kit, and the Sleuth Kit is a popular program used in digital disk forensics. We're going to be using it from the PicoCTF web shell, so it's not PicoCTF, it's called Scilab now. We'll be learning some basic operations of the Sleuth Kit in this workshop to learn about digital disk forensics. Okay, so let's get acquainted with the Sleuth Kit with this PicoCTF challenge over here. So you're going to need to be logged into Scilab. So PicoCTF became Scilab Academy. If you're not signed up, you can go over here to sign up for the website. Once you're logged in, let me get the challenge. So the first challenge is Sleuth Kit intro. Let me get that link. Okay, so SleuthKit intro, here's the link if you want to join along with us. And let's see, download the disk image and use MMLS. So, okay, let's take a look at the challenge and let's read what it wants us to do. So this is the SleuthKit intro challenge from Scilab Academy. It says download the disk image and use MMLS on it to find the size of the Linux partition. Connect to the remote checker service to check your answer and get the flag. So it says note if you're using the web shell, download and extract the disk image into /tmp, not your home directory. Okay, so what we want to do first is we want to open up our web interface. So our web shell, rather. So we can click on this big orange button here, open in workspace. And what we want to do inside the terminal here is we want to right click on the terminal and then we want to go down to this frame. So this frame, this web shell terminal, we want to put it in its own browser tab. So we can select open frame in new tab. Ahmed, hello, nice to see you here. What is up? Okay, then go over to the new tab, which is the web shell. So the web shell is a web accessible Linux terminal. And we're going to be using this to solve the challenge. We're going to move into the temp directory, so cd/tmp, and then we're going to download the image so that we can take a look at it. Okay, and then go over to the challenge, and there's a link that says download disk image. So we're going to right click on it, then we're going to select copy link, and then we're going to go back to our web shell. Then we're going to download the image. wget space, and then paste in the image. Actually, I'm pretty sure we're not going to be able to take a look at the temp directory. I mean, we can download it here. Huh. Oh no, this is my temporary directory. Well, I mean, it's good that we can see this. Okay, let's go ahead and wget this down. So wget space, paste in our file address. It's going to take a little while to download. Okay, and then after this is done, we should see the disk.img.gz file over here. So this is a .gz file, which means it's compressed. What we need to do is we need to uncompress this file using the gunzip command. So gunzip space, and then the name of the file. So it's disk.img.gz. So give this command to unzip the file. And afterwards, you'll see this disk.img file over here. So this is a disk image file, and what we want to do is we want to examine it using some of the SleuthKit commands. If we run file on disk.img, it tells us that this is a DOS/MBR boot sector, partition 1, and then it tells us some additional information. So this is a disk image file, and what they want us to do in this challenge is to run the mmls command on it. So mmls, it basically tells you what file systems are on a disk image file. If we go back in and we run mmls on disk.image, it tells us that there are 3 different sections. So there's a primary table, there's an unallocated section, and then there's a Linux file system. So the Linux file system is located starting at this byte over here, and it ends at this byte over here. So this particular image like I said, has 3 different sections. So the challenge is asking us to do what? Find the size of the Linux partition. Okay, the size of the Linux partition. So if we go back to here, if we take a look at the length of the Linux partition over here, this is the answer for the challenge. So this is, I'm guessing that this is bytes. So it's 200,000 wait, no, it's 202,552 bytes. Anyways. Okay, so to solve the challenge, we're going to go over back here and we're going to start the instance. So click on Launch Instance down here in the challenge. And then they're going to give us a command that we can use to access the challenge. So copy the command. So this is a netcat command to the server on this port. Copy that command, go back to the web shell, paste in the command, and then hit enter to run the command. So it's gonna, the server asks us, what is the size of the Linux partition on the given disk image? So lengthen sectors. Oh, this is sectors, not bytes. Okay, so either way, copy the number, paste it in, and then hit enter. Did I? Oh, I copied the wrong number. That's a typo. That's a typo, everybody. So that's the shy31 typo. Anyways, we don't want to make typos. So we want to copy the length over here. So copy the length, paste in the length, and then hit enter. Oh, we have to run the command again. Okay, and then it says great work, and then we got our flag. So the flag is what we need to submit to the challenge to finish it. Okay, so copy the flag. So here we learned how to use one command from the SleuthKit suite. So the SleuthKit set of tools. So MMLS is going to let us know how many partitions exist inside of a disk image, and it'll tell us the start location, the end location, and the length of the disk image, or the length of the partition. Okay, we'll go back to the challenge. We will scroll down to the bottom, and then we'll submit the flag over here. Click on Submit Flag, and then we're done. It says correct flag. Okay, let's go ahead and talk about this. So in this challenge, we use the MMLS command. So the MMLS command displays the media management of a disk image file in a list, or LS format. So media management list. So that's the MMLS command. So we can see where the partition starts, the offset in bytes, where the partition ends, and the length size of bytes of the partition over here. And thank you very much for following on Twitch. Pifatzi. I'm not too sure if that's the way you can pronounce it. Okay, so we're going to learn more about the SleuthKit commands through this challenge right here. It's called SleuthKit Apprentice. So it's the same kind of thing. Before we start downloading stuff, we should probably clean up our environment first. So we'll go back into the web shell. We'll hit Control-C to exit out of the program. And we're just going to delete the disk image here, because we're done with this. We have a limited amount of space to work with inside of the web shell. So rm space disk.img, and that gets rid of that file. You can call me Slash. Oh, okay. It's probably better because I'm not gonna be able to pronounce your name probably. But hello, Slash. Nice to see you here. Okay, so we'll go back. Yeah, I see occasional errors in my stream health. Huh. Okay, let's move on to the next challenge. So the next challenge is going to be SleuthKit Apprentice. Okay, let's... Alright, so in SleuthKit Apprentice, and this is the link for the challenge, if you want to follow along. It says here, download this disk image and find the flag. Note, if you're using the web shell, download and extract the disk image into temp, not your home directory. Okay, download compressed disk image. So they've got a link over here. We're gonna, just like the last challenge, we're going to highlight the link, right click it and select copy link. Then go over to our web shell, and we're gonna have to go into the /temp directory. Okay, so cd space /temp. This moves us into our temp directory, and from here we can download the file. So wget space, right click, paste in the file address, then hit enter. So it'll take a few seconds to download. April says, is SleuthKit Autopsy? So SleuthKit is the CLI implementation of Autopsy. Autopsy is the GUI, or the graphical user interface version of SleuthKit. So Autopsy is built on top of SleuthKit, and it uses a lot of SleuthKit commands in the background. So let's talk about it very briefly. Digital disk forensics, SleuthKit, and Autopsy. So SleuthKit is the original tool, or the original suite. SleuthKit is terminal only. Autopsy is the GUI implementation of SleuthKit. Uses SleuthKit commands as part of its operation. Okay, so let's go back. So we downloaded the file into our temp directory here. So we need to decompress this file. So it's a GZ file. We need to gunzip this file. So gunzip disk.flag.image.gz. This is taking a while. Because it is a big file, and then afterwards we see disk.flag.img. So if we run file on this particular thing, it says it's a DOS MBR boot sector partition 1, partition 2, partition 3. So there are multiple disk partitions on this particular image file. What we want to do is we want to use some additional commands to get some information out of here. So let's take a look at the challenge. So download this disk image and find the flag. Okay. So if we go back in, the first thing we're going to do is we're going to run the same command we ran previously. So that's mmls on disk.flag.img, and it'll tell us where the different partitions are. So there's a Linux partition here. So there's 3 different Linux partitions: statistics or stats, associated with the file system or FS. So when we run the fsstat command, we have to give the offset of the partition we want to look at. So in this case, it's going to be offset 2048 over at disk.flag.img. So to use this command, we need to supply the byte offset of the disk partition, -O and the name of the disk image. Okay, so let's go ahead and do that. So in our web shell, we see here that there are 3 partitions, and these are the offsets right here. So the offset for this partition is 2048. The offset for this partition is 206848, and then there's another one as well. Okay, so we're going to run the fsstat command, fsstat space, and then we have to give the offset of the partition we want to look at, which is 2048. SysOS says, I really need to switch to YouTube because Twitch is being annoying for me more and more. Twitch is being annoying for me more and more. You know what? I'm gonna have to go in and take a look at my broadcasting software because it might have something to do with my broadcasting software and not Twitch itself. Anyways, so fstat-o, and then we give the offset 2048, and then space, and then we give the name of the file we want to look at, which is disk.flag.img. Okay, so when we give this command, it'll give us a bunch of information about the different blocks of file information. So what we want to, the most important information we want to get from the fstat command about each one of these partitions is the file system type that is being used, because sometimes we need to supply the file system type when we're running additional commands. So in this case, this partition is associated with file system type ext4. So ext4 is a common file system type for Linux. April says, I'm getting some infrequent pauses over on YouTube as well. So yeah, after the stream is over, I'm gonna go back in and do some diagnostics on my streaming setup. Okay, so we know that this is ext4. We're going to need to supply ext4 in the next commands. So the next command we're going to be learning about is this one, the fls command. So the file system list, so fls stands for file system list. This command is used to list out files and directories within a specified file system. So we would run fls-f for file system format, in this case it's ext4, and then an offset 2048 -r. So -r is going to make the command recursive. To run this command, we need to the format of the file of the disk partition -f, the offset of the disk partition -o, and then run it recursively -r to see what's inside of these directories. And we also need to supply the disk image name. So let's go ahead and do that. So in here, we can use the previous command, so fstat, but just replace the name of the command. Replace it with fls, -r for recursive, and -f to provide the file system type, which is ext4. So this is the full command right here. I'll provide it for reference. Okay, and we see here that there are a bunch of different files on the system. So we see lost and found, ld linux.sys. So the thing is that I'm pretty sure this is not the file system we want to look at. And we saw earlier that there were 3 different partitions. So yeah, there are 3 partitions here. I think the one that we want to access is this one at offset 36,000 something something. So we're just going to copy this, and we're going to run we'll run the ffstat command at this offset. It'll tell us that this is also an ext4 file system. So we're going to supply this to the next command, which is the fls command. So we'll just run the fls command, but we'll replace the offset. So the offset's not 2048, it is this other number, so 360,000. Okay, when we run this command, we see the entire file system contents of this partition, and we want to check to see if there's a flag file on here. So what we can do is we can just pipe this into something like grep. So we run the same command, pipe into grep, and look for flag. And we see here that there's a flag.txt file here. So flag.txt, when we're dealing with the files on the file system from a forensics point of view, we need to understand the inode number of the file. So each file on a Linux file system has a inode number that is associated with the file. Flag.uni.txt. uni.txt. So we also see this designation over here, so realloc. So realloc, I think this indicates that this file has been deleted, which means that that this particular inode has been assigned as something that can be written over. So APK, is this Android? I don't think so. But I haven't investigated too much about this. Okay, so where's our presentation? fstat command, fls command, the icat command. So the icat command, so icat stands for inode cat. This command is used to read specific files in a disk partition according to its inode number. So if we have got the inode number, we can use the icat command to read the file. So let's go ahead and try this on the two files that we found. So there is flag.txt and there's flag.uni.txt. So to run this, we'll run icat and then give the file system ext4, the offset, and then the last thing we need to give is the inode number. So we know that there's one inode number here for flag.txt, which is 2082. 2082, okay. Okay, and then we run icat on this, and then we see some numbers. So the reason why we see numbers here is because this file has been deleted. The other thing we see here is the flag.uni.txt file here. So we can give the inode number for this and try to read this as well. So it's 202371. So this is the actual flag we're looking for. So we'll copy the flag. And then we'll go over to Scilab, scroll down to the bottom, and we'll paste in the flag, click on submit, and then we're finished with this challenge. So we used a few different commands as part of this challenge. Let's review them really quick. So we use the mmls command, the fstat command to get statistics associated with the file system, which is important for learning the type of file system that we need to give to other commands. In this case, it's ext4. So we use the fls command to get the contents of the file system. We need to pair this with an offset for the partition. We need to run it recursively to see everything, as opposed to just the directories. And then we use the icat command to actually read the files. Okay, so the last challenge we're going to be covering today is called Operation Orchid. So let's go ahead and access that challenge. Okay, need to rewatch the stream later to refresh my DF disk image skills. I mean, you're going to see a bunch of different challenges on in CTFs that deal with disk image forensics. SleuthKit is a very convenient suite of tools you can use to do disk image forensics. It's not the only tool you can use, of course. There's a bunch of tools out there. Okay, so this is the Operation Orchid challenge. Let me get you the link. Okay, so it says here, download this disk image and find the flag. So if you're using a web shell, download and extract the disk image into your temp directory, not your home directory. So before we do that, we'll go back into our web shell and we'll do a little bit of cleanup. So there's we want to get rid of this file here because we've got a limited amount of space we can use for storage. So just remove the disk image disk.flag.img file. SysOS says the tool I used to use was XXD, and that's just painful. I mean, XXD certainly has its uses. It's not the only tool to use, of course. Okay, so we'll go back and we'll copy the link for the new image, the disk image file. So there's a link here. Right-click, copy link, then go over to a web shell, wget space, paste in the file address, hit enter. That will slowly download the disk image. It'll be done in just a second. Okay, progress done. Great. Okay, so this is compressed, of course, so we need to uncompress it. So gunzip disk.flag.image.gz. It's going to take a little while to run because this is a large file. But then afterwards we'll have our uncompressed disk image file that we can play around with. Okay. So we'll run file on this thing, and it looks like there are a bunch of different partitions on this disk. So there's there's 3 different partitions. And we can run our usual commands. So mmls on disk.flag.image. And we see here that this looks very similar to the last challenge. So there's a Linux partition at 2048, and there's another Linux partition at 411,648. Okay, so what we're going to do first is we're going to run the commands that we ran in the previous challenge. So remember that after running our mmls command, we can also run the fstat command. Bazrikia, hello, nice to see you here. What is up? Okay, so fstat space -o for offset, and I'm pretty sure the partition we want to look at for this challenge is the last one here. So we're going to give the offset for this partition, and then we're going to give the image file name here. So this is the next command. I'm going to pipe this into head because we actually we don't need all the information from this command. We just want to get the file system type. So the file system type being used here is ext4, and we're going to be using this in our next command. So the next command is going to be fls to see the file system list. So we run the previous command. We're just going to replace fstat with fls -r for recursive, and we're going to give the file system type, which is ext4. So this is the full command. So this lets us see the file system list for this particular disk image. So this is a lot to pay attention to here. So what we're going to do is we're just going to look for what we're interested in. And what we're interested in is something called like flag something something. So we're going to grep for flag. So we see flag.txt, and we also see flag.txt.enc. So I think another thing we could pay attention to, here, is we could pay attention to the root directory. So if we wanted to look for just the root directory, we could grep for root. So there's a root directory over here. So with this inode number here, 472. Mexicant says, can we assume that it's encoded? Yeah, so flag.txt.enc is probably encoded. So what we need to do is we need to figure out how it was encoded first, and to do that, let me take a look at my notes. Oh. Okay, so in the web shell, I'm pretty sure we can take a look at just what's in the root directory here by doing fls. I think I need to look this up. Let me do a quick search. So let's see, sleuthkit fls command only one directory. Okay, to list the contents of only one specific directory using the sleuthkit fls command, you must provide the inode number of the directory as an argument. Okay, so that's easy enough. So we just need to do fls, and we need to supply the inode number. So typically this is the last thing you give in the command. So the inode number is this number over here. So the root directory's inode number is 472. And we see that there are three files in this directory. There is flag.txt, flag.txt.enc, and .ash history. .ash history, this is actually a very big find, because if we know what commands were run, well, this has the history of the terminal for the root user. So the root user might have been running some interesting commands. What we want to do is we want to find out which commands those might have been. So we would run icat on .ash history. So the number we want to use is 1875. And we want to run icat. So this is the command we run over here. Okay, so we read the .ash history file and we see touchflag.txt. So they created a flag, and then in nano they probably gave the what is it called? The contents of the flag file over here, and then they ran OpenSSL. So OpenSSL is a program you can use to do different encryption operations. So in this case, they ran OpenSSL to encode flag.txt to create a file called flag.txt.enc, and they gave a particular key, which is unbreakable password 12345667. It's a tiny distribution used for many Dockers. Which distribution are we talking about? Oh, Alpine. Yeah. Alpine is a very, was it security-focused distribution of Linux? Okay, so the last command that they created this, they created this encrypted version of the flag, and then they shredded flag.txt. So the difference between the rm command and the shred command is that the shred command is going to get rid of all the information that was at that particular inode, and that is going to prevent people from doing forensics to get the original value of the flag.txt file. Alright, so if we know the key that was used to encode a particular file, we can do the opposite operation with OpenSSL. So we basically run OpenSSL in reverse. So I'm pretty sure I've got like a write-up for this. Just a second, let me go and get that. I think I might have put it in my session notes. So this is session 5. Okay, So we can use OpenSSL to decrypt the flag using this command over here. So this is the command. And before we run the command, let's talk about what the command does. So the OpenSSL command is used to run an AES-256 encryption decryption. In this case, we're running it in decrypt mode. And we need to supply a salt. So the salt that we provide was created from this key over here. So unbreakable password 12345667. We're going to pass in flag.txt.encoded, and we're going to output flag.txt, the original file. So when we run this, well, the first thing we need to do is we need to actually get the flag.txt.enc file here, because we actually don't have it on our file system. So we'll go back into the web shell, and we're gonna cat out the flag.txt.enc file, and we're gonna output it into an actual file. Is it not in the beginning of the file? It might be. It might be. Let me check. So we're gonna run icat again, and we're gonna run icat on flag.txt.enc to get the encoded version, the encrypted version of the flag. So run icat on inode 1782. And we're going to output it, we're going to redirect the output into flag.txt.enc. Okay, so after that, we've got our own version of flag.txt.enc here. And we'll xxd this. And it says that this is a salted file. We don't see the actual value of the salt here, but we know what command we can use to get the original file back. So let me copy that again. Where did I put that? Here it is. Okay. Okay, so we'll just paste in this command here. So OpenSSL, we're going to take in flag.txt.enc and then output flag.txt. Okay, so deprecated key derivation used. So I mean, it's fine. The result is that we actually have flag.txt here. So we can just read it out. And it's PicoCTF haunting past. Okay, so we were able to use all of our commands. So the FLS command, the icat command, the fstat command, and we're able to get information about the disk image and then extract the encoded flag or the encrypted flag, and then we decrypted it. Diapril says the salted result from XXD is like salted like magic bytes, or is it something that's interpreted by XXD? So in here, the resultant file, the encrypted file. Oops. This is actually identified by the file command as an OpenSSL encrypted data with salted password. So the salted password, we don't know it, but we do. Well, I mean, we were able to get the salted password by reading the history file. So that's why we were able to determine the command over here. So -k, so for key, unbreakable password 12345667. Okay, so anyways, let's complete the challenge by copying the flag and then submitting it to the challenge down here. Submit flag, and we're done. Okay, so let's review the digital forensics concepts we learned in this workshop. if you take a look at like CTF challenges, you're going to find quite a few that have you investigating like disk images, and the sleuth kit is a very good set of tools for investigating disk images. So you'd use commands like mmls, fstat, fls, icat in order to investigate these without actually mounting the disk images. Sometimes you can mount the disk images if they're like, you know, Linux disk images to investigate them in a more natural way, but sometimes you want to use the disk image forensics tools in order to be able to access stuff like deleted files, which you normally wouldn't be able to do if you mounted the system. Okay, so the sleuthkit software. So the sleuthkit is a popular program used in digital disk forensics and includes several useful commands for interacting with disk images, including the mmls command to see what partitions are on a particular disk image, the fstat command, which lets you know the type of file system that's being used by a particular partition. And what's next? In the next HackerFrogs AfterSchool Digital Forensic Workshop, we'll take a look at a different program to look at disk files in a more intuitive way. So we're going to be taking a look at the other program that is associated with sleuthkit, and it's called Autopsy. So Autopsy is a GUI powered version of the sleuthkit essentially, and we're going to be taking a look at that next time. But let's stop the counter. And what we're going to do is we're going to try doing some demonstrations for PicoCTF challenges, because I've got like 2 left to demo, and then we'll get on into our last portion of the stream, okay? So let me get away from here and let's do our next demonstration. So we did Hashgate. Okay, the next one is actually kind of interesting. This is taking a look at a 2FA or two-factor authentication, or like a bad implementation of two-factor authentication. We'll talk about this in just a sec. So this challenge is called No FA. Commercials on YouTube are more obnoxious than on Twitch, I can tell you that. I mean, the good thing about the commercials on Twitch or on YouTube is that you can, most of the time you can skip them, which makes it a little bit more palatable. Okay, so no FA. Here it is. Okay, so if you want to follow along, this is the link. Okay, let me do my YouTube intro. Alright everybody, this is a guided walkthrough for the No FA challenge from PicoCTF 2026 as part of their web exploitation set of challenges. So the description of the challenge says, it seems like some data has been leaked. Can you get the flag? And we're actually going to get more information after we click on this button over here, Launch Instance. Okay, so after we launch the instance, we see some additional information. It says you can get started here to find the flag. The application code can be found here, and the leaked data can be found here. So what we can do is, well, first of all, we need to download these 2 files. So the application code and the leaked data. And in order to interact with this, we're going to want to access our web shell. Click on Open in Workspace. And then after this terminal starts up, we want to right click on the terminal and then navigate down to this frame and then click on the Open Frame in New Tab button over here. So this is going to put the terminal in a separate browser tab over here. And we're going to create a directory we can work inside of. So this is called NoFA. So we're going to make a directory called NoFA and then enter that directory. Okay, so from here, we're going to download the 2 files that they mentioned in the challenge. So there is a link. The leaked data can be found here. So right click on this, select copy link, go to the web shell, paste in users.db. So this, oh, sorry, we need to do wget in front of that. Okay. So I'm actually, there's actually one part of this challenge that you actually can't do on the web shell, but actually maybe you can. Yeah, no, there's one part of this challenge that you can't do inside the web shell. We'll talk about that later. Okay, so the first thing we're going to be taking a look at is this users.db file over here. So there's app.py, which is the source code of the application. There's also users.db. So the first thing we're going to be taking a look at is this database file. We can run file on users.db, and it says this is an SQLite 3.x database, which means we need to interact with this using a specific program. So SQLite 3 space and then users.db. Okay, so from here we're inside of the SQLite database program. There are a couple of commands we can do to take a look at what's inside this database. So the first one was .tables to let us know what tables exist in the database. And the second one would be to check the schema to check the columns for the users table. So .schema space users. So that there are these different columns. There's the ID column, the username column, the email column, the password column, and the 2FA column. So if we take a look at everything in the table, we would have to give this command. It's going to be select star from users, and then we put a semicolon at the end. This will let us know all the information from all the different columns in this table, or the different rows. This is a bit hard to look at, but let's try to dissect this. So the ID number is here. The username is this over here, John Doe. The email is john.doe@nfa.com. The password is not the actual password, but a hash. So this is a password hash. And then there's 2FA. So 2FA is Boolean, default 0. So we see here that most of these users have 2FA. They don't have 2FA enabled on their accounts. But there's one user here called admin who does have 2FA enabled on his account. Okay, looks like we've got problems with our streaming right now. Seems to be happening every how many minutes? Yeah, it's pretty frequent. Okay, SysOS Master says only admin has 2FA. Yeah. So the thing is that this kind of list over here, what we could do is we could try to crack all the passwords. Since we have the usernames and the password hashes, we can try to crack the passwords with a separate program. So in order to do that, Saint of Vice, hello, bold title. Yeah, we're going to be doing our bank hacking, well, our quote-unquote bank hacking stuff a little bit later. And we're going to be hacking a CTF box called Bank. So I'm not lying, it's just that it's a CTF box and not an actual bank. Okay, so hold on, let me get the commands we're going to be using to get our information, just a sec. Okay, so what we want to do is we want to create a list or a file which has all the usernames and passwords, or now the password hashes. So we're going to run this command over here, separator semicolon. Separator. Yeah, separator semicolon, which is going to separate all of the columns by semicolons, sorry, not semicolons, colons instead of the pipes. Then we're going to select username and password from the user's table. So this is going to get a format that we can use when we do our password cracking attack. So we're just going to copy all this, and we're going to copy it over to our local machine. Yeah, John the Ripper for example. Okay, so we're going to move over to our Kali Linux machine because we don't have our password lists on the web shell. So over here, let's see. So the NoFA directory. Okay. What we're going to do is we're going to create a file called userhashes.txt. Actually, let me get rid of this file first. Okay. Nano space, and we're going to call this, yeah, userhashes.txt with nano. Daypro says, "Are you affiliated with Scilab Academy? New source for me." No, I'm not affiliated with Scilab Academy. I mean, it would be great if I were, but Scilab Academy used to be PicoCTF, and PicoCTF is very well known. Looks like we've got ads running on Twitch. When ads run on Twitch, we're going to take a little break, and during the break, we'll put on the birds. Where are our birds? How about a squirrel instead? Okay, here's a happy gray squirrel. It'll be back. We'll be back in about 60 seconds. I just need to take a little water break. Dapro says, I didn't know that they rebranded. Yeah, I mean, they rebranded within like the last month or so, so it's actually not a lot of people know about it. Wild Radio Root Squirrel. Yeah. I mean, these squirrels are they're pretty fun to watch. Agent 57 says no raid. No, we're not quite finished the stream, but hey, Agent 57, nice to see you here. Okay, let's put the squirrel away. Let's get back to the hacking stuff. Okay, so userhashes.txt. We're inside of Nano now. We're going to paste in all of the usernames and password hashes over here, and then we're going to save this file out. So Control X, save modified buffer Y for yes. Hit Enter to confirm the file name, and then we're going to try to crack the hashes using a common password cracking program called John the Ripper. And in fact, let's review what we did up until this point. So this is PicoCTF 2026 NoFA. In this challenge, we're given a database file to inspect, the source code for the web app, and asked to compromise the website. So we can use the SQLite program to enumerate the database for useful information. And in the database, we see that there are user password hashes, so we can attempt to crack them. So as for what kind of hashes are used by the SQLite system, if you do a quick search, you can find out which kind of hashing is used by SQLite 3. Okay. So let's see, internal symbol management. Internally, SQLite uses hash tables to manage its symbol tables. And let's see. External content verification. Okay, it uses a SHA-1 hashing algorithm. And application level hashing, so let's see, does not include built-in SQL functions for hashing. So let's see. After doing some research, you find out that these password hashes right here are SHA-256 hashes. So what you want to do is you want to feed these into John the Ripper with this command right here. So John the Ripper is going to try to find out what the password hashes were originally by running it in raw SHA-256 mode, and we're going to run it on userhashes.txt. The word list that it's going to use to try to figure out what the original passwords were is called rocku.txt, which is a list of, I think it's like 14 million of the most common passwords. I don't remember how many million it is. It's a lot. Okay, SQLite has no built-in hash. You provide them directly into the database in the application. Oh, okay. So you'd need to supply, like, I want my passwords to be hashed with SHA-256 or SHA-1 or MD5 or whatever. Okay, so run John. Very quickly, we're able to crack these hashes. So we found two. We're only interested in the admin hash, of course. So admin, this user has the password apple@123. So we can use this to try to log into the application. So here's what we're going to do. Let's see. Is my instance still running? It's only running for 1 minute and 28 seconds. We're going to restart this. And then we're going to take a look at the website. So here, log out. Let's just ignore the fact that the flag was just sitting there. Anyways, we're going to try to log in as the admin user. So it says the operation in the app and then send the results. Oh, you do the operation in the app and then send the result to the SQLite database. Oh, okay. Okay, so here we're going to supply admin as the username, and the password is apple@123. $17 million is very short, is it? Okay, we click on login. And then we see here, there's something called the OTP verification. So enter the OTP sent to your registered email. So we don't know what the OTP is because we don't have access to the email. So this is where we have to take a look at how the OTP is being handled by the application. So if we go over to the source code that we downloaded earlier, app.py, and we take a look at it, we see that inside the application, if a user has 2FA enabled, then they need to generate the OTP. So OTP equals some random number between 1,000 and 999, and then they're going to store it inside of the cookie. So session something something lets us know that this is being stored inside the cookie, and this is a Flask application. So where is it? So the OTP secret is a number, and it's being stored in the cookie. So if we can decode the cookie, we can get the OTP secret from there. So this is how we're going to do it. If we go over to the web browser, we should have a cookie now. If we go over to the browser, more tools, web developer tools, and then we look at the storage, we should see a session cookie with this value right here. We're going to copy the value, and then we're going to keep it around somewhere. So I'm just going to paste it over here. This is our cookie, and what we can do is we can create a script that decodes the cookie. So decode flask cookie.py. Here's a little script that I wrote. with the help of AI, of course. And what does this do? So what this does is it takes in a Flask cookie and it decodes it. So we need to provide the cookie value as part of as the argument to the script. And what this is going to do is it's going to let us see what's inside the Flask cookie. Okay, so we run Python decode Flask cookie, and we're going to paste in the Flask cookie that we have for the application. So this is what's inside the Flask cookie. So username admin, OTP timestamp this, OTP secret is this number right here. So the actual OTP secret, you don't need to get it from the email. If you can read the cookie and decode it, you can read this. So 9341 is the cookie, is the OTP value. So 9341, and then click verify and login. Okay, invalid OTP or OTP expired. Okay, we're gonna have to be a little bit faster about this. So let's go back home. We're going to try to log in again. So it's admin app apple at 123, and we're going to get our new cookie. So we need to do this a little bit faster. Where's our storage? Storage cookies here. Okay, we're just going to copy the cookie. We're going to very quickly run the Python script. Talk about bad bad OTP practices. Yeah, that's I mean, there are a few different ways you can get past OTP or 2FA. So 3700. Okay, let's very quickly put it in. 3700. Verify and log in. And then it says login successful. So we were able to read the OTP value from the cookie, and we get the flag. So PicoCTF, no rate, no auth. No rate, no auth. Okay, so let's grab the cookie value here. Sorry. Grab the cookie value here and submit this as the flag. So back at the challenge, go down to the bottom, paste in the flag, click on submit flag, and you're finished. Okay. So if you're wondering where I have the code for this Flask decoding script, I'm pretty sure I've got it in my GitHub notes over here. So let me just check. No, I don't. Okay, let me very quickly create it over here. So this is what? No FA? Okay, so I'm just going to leave this blank, and I'm just going to put in the Flask cookie decoding script over here. So this can come in handy anytime you're dealing with an application that uses Flask cookies. Let's commit those changes. Let's see. SysOS Master says, does it split the string on the dot and do a base 64 on the remaining parts? I mean, I'm not. Hold on. Let's take a close look at this. So it does decode Flask cookie. This is a function. Okay, so payload is the cookie. If the payload starts with a dot, then it is compressed, and then we have to do something else to it. So it splits the data on the dots. Yeah, it does run base 64 decode. So, I mean, I guess that means we could do some manual decoding on this as well. But let me go ahead and finish up the challenge first. Alright everybody, this was a guided walkthrough for the No FA challenge from PicoCTF 2026, as part of their web exploitation series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, there is SysOS says there is a zlib compression possibility. So, I mean, if it's a compressed flag, or I mean, sorry, a compressed cookie, that means that we can't. That means that we can't just grab some part of this and decode it. Actually, wait, let me just grab... So there's one part of the cookie up until here, I'm guessing, that we might be able to base64 decode. Let's give it a try. Nope. So it looks like... Yeah, so we need to decompress this first before we can base64 decode it. Anyways, let's do the last walkthrough, and then we can do our final task for today's stream. So the last one is it's a pretty easy challenge. We should be able to finish it up pretty quick. So this one's called Old Sessions. And this one also has an interesting tech aspect to this. Okay, so this is Old Sessions. Let me grab the file. Grab the GitHub link. Yeah, if you want to take a look at all the write-ups that we do, you can find them on the GitHub. Okay, so let me start the challenge. We should be able to finish this in just a few minutes. Alright everybody, this is a guided walkthrough for the Old Sessions Challenge from PicoCTF 2026 as part of their web exploitation series of challenges. The challenge description says, proper session timeout controls are critical for securing user accounts. If a user logs on a public or shared computer but doesn't explicitly log out, and instead simply closes the browser tab, and session expiration dates are misconfigured, the session may remain active indefinitely. This then allows an attacker using the same browser later to access the user's account without needing credentials, exploiting the fact that the sessions never expire and remain authenticated. So this is something called session fixation, which is a big problem. It basically means that cookies never expire, and cookies are linked to session management in web apps. Additional details will be available after launching your challenge instance, so we're going to launch the challenge instance. And it says, browse here and find the flag. Okay, so we're just going to take a look at the website. Okay, so, So the login page is over here, username and password, and we can register a user. So on any web application challenge where you can register a user, we probably want to do that. So we'll register a user, well, we'll click on register, and then we'll register test user with the test password, confirm the password, and then click on register. Okay, so now we can log in using the user we just created. So test, click on login. And we see here on the home page that we've got some comments. So it says here, this site is cool. And Mary Jones says, hey, I found a strange page at /sessions. Okay, hey everybody, hello world. So we were told about a particular endpoint on this application at /sessions. So we can just copy this and we can append this to the end of the URL. So when we arrive at this endpoint, we see some interesting stuff. So we see here session and then some value, and then some values associated with this. So permanent true key test. So key test, this is the name of our user. So our user is test, and our session value, our session cookie actually is right here. So LMexCan says, I find it funny that the admin didn't delete that comment. Maybe the admin is not paying a lot of attention in general. Okay, so there's this other session over here that has another value here, and it says the key is admin. So we're assuming that this is the admin's cookie value. So just to make sure that this is actually what we're actually looking at, we can click on More Tools, Web Developer Tools, and then take a look at the Storage tab. So in the Storage tab, we can see cookies, and so for our user, we see that the cookie value is this. So it's Q__WWLZ, and we can see here that this is actually our cookie value. So this is the same cookie value that is listed on the session's endpoint here. So if we wanted to, we could become the admin user by selecting everything in their session value here, and then copy it, and then go into our cookie here, double click on the value, delete what we currently have, paste in the admin user's cookie value, and then reload the page. So hit enter, reload the page, and to make sure that this actually worked, what we would do is we would just go back to the home page. So just delete the word sessions, hit enter, and it says welcome admin. So we're actually logged in as the admin user because we stole their cookie value, and we get the flag PicoCTF set session expiration. So before we finish up, we'll do a little review. So PicoCTF 2026 old sessions. In this challenge, we're told about misconfigured web apps that don't delete user sessions when the user logs out. So we're dealing with something called non-expiring cookies, or sometimes it's called session fixation. So after registering a user and logging in, we see a message from a user mentioning a /sessions endpoint. So on that page, there are session values that can be put into cookies. So we say that we can get the session value, we can paste it into our cookie, and then become the admin user. Okay, and what we can do is we can hijack the session by pasting the admin session value into our cookie. So as Master says, if you think, how could anyone make such a page? You often find this type of weird debug page in custom-made applications. Well, I mean, this kind of endpoint might exist when you're doing debugging, when you're doing the development of the application, but the problem is that this particular endpoint was not deleted before the application was put into production. Okay, so let's go ahead and finish up the challenge. So we just need to go over to the web page. Where is it? Here. Grab the cookie. Sorry, not the cookie, the flag. In the challenge description, paste in the flag at the bottom over here. Submit the flag, and then you're finished. Alright everybody, that was a guided walkthrough for the Old Sessions Challenge from PicoCTF 2026 as part of their web exploitation series of challenges. If you enjoyed this challenge walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. And grab the cookie, also known as the flag. Yeah. Alright everybody, let's go ahead and get to that bank hacking now. So we're going to give ourselves, we'll give ourselves like a couple of hours to do this challenge. So we'll put 120 minutes on the clock, and this challenge is the bank challenge from the Vulnyx platform over here. So if you wanted to do this one yourself, what you want to do is you want to download the virtual machine and then put it on the same network as your attacker machine. If you don't know how to do that, then the first thing you want to do is you want to make yourself a security-oriented virtual machine that you can do hacking with. So something like Kali Linux, I've got a video that covers how to do that over on my YouTube channel. Let me see if I can find it. Here it is, okay. Hopefully this is still relevant, because sometimes the software updates and it's not relevant anymore. Okay, so the first thing we're going to do is we're going to start up our virtual machine. So I've taken the liberty of downloading and deploying the virtual machine to the network. I just need to start it up. So for this challenge, and before we get underway, let me go ahead and put up the current topic here. Kali installs have pretty much been the same for the past 10 years. That's good for me. That means I don't have to make a new video. Okay, so we've started up the virtual machine that we need to hack against. And I just need to wait for it to tell me what IP address we're dealing with. Okay, there's a bunch of different tools that we're going to be using to do this hack. The goal of this particular exercise, I mean, we can talk about it before we get underway. So this is a CTF box challenge. The name of the VM we need to hack is called bank. Might look updated though. Yeah, that's what happens when the UIs change. So the name of the VM that we need to hack is called bank. This VM is deployed on the same network as our attacker machine. A Kali Linux VM. Okay, so our goal is to identify an insecure app or network service on the VM. Get initial access. Are we cracking Swift tonight? I don't know. I don't know if Swift is going to be involved in this. Okay, so our goal is to identify an insecure app or network service on the VM. Get initial access to the server via some exploit that the services are vulnerable to. And then once on the server, elevate privileges until we have the highest level of access. Are you looking for a swift kick in the HackerFrog? Well, we're not looking for that. It might happen to us regardless. Okay, so this is what we're doing over here. So we just need to hack against the vulnerable virtual machine until we get super user access. So the first thing we need to do is we need to scan the machine to see what network services are hosted there. So we run nmap. I'm pretty sure this is the, yeah. So this is the IP address of the machine. Okay. So Nmap is going to scan the machine. It's going to let us know what ports and services are available on this particular server. It tells us there is port 80, there's port 139, and port 445. So these have been identified as HTTP on port 80. Running Apache HTTP version 2.4.66. So this is an Apache, a Linux Apache web server. Well, I mean, we don't know for sure that it's Linux, but we've got a pretty good indication. So this page also redirects to a domain called bank.nix, which means we should probably add this domain to our etc host file so that we can resolve it properly. Okay, port 139 is Samba. So Samba is the Linux implementation of the SMB protocol, which is a very common file sharing protocol that's common to Windows systems. Okay, so the first thing we're going to do is we're just going to add bank.nix to our list of domains. I'm just going to copy this, and then we're going to go into our regular text editor, sudo nano etc hosts, so that we can edit this. Okay, so this is bank.nix, and the IP address is Funky Monkey. Hello, nice to see you here. What is up? We're just doing some hacking against a machine called bank. Okay, we're going to save this out. So this means that we can successfully resolve the bank.nix domain. So if we navigate over to http bank.nix, okay, we got a big web app here. Okay. Traditional banking for the digital era. So I mean, we could probably look at all the links over here. Most of the time on these CTF boxes, the web app isn't really very functional because they don't want to code an entire app when in fact they want to. This is just kind of like a shell. What is this? Join waitlist. Test at test.com. This doesn't do anything. Okay. So the other thing we could do is we could take a look at the source code and see if there's anything hiding in the comments. So we don't see any real links here. There are no links. This is mostly just text. Okay, so the other thing we could do with this website is we could start doing something called directory busting. So directory busting is a technique you can use to try to figure out which web pages and directories exist on a particular website. So let's see, it counts as fuzzing. We're gonna just run a very simple directory busting command called dirb. So index.html, that's the page we're looking at. Code 200, it's pretty big. Alright, so that was dirb. We can also run nicto. I think we need to specify like a target. Nicto, is it like U for URL? Just a second, I've forgotten my nicto syntax. I haven't run nicto in a while. History. Yeah, so it's like, it's gonna be either T or like U. No? Is it? Hold Just a second, everybody. I need to look up how to use Nikto again. -H. Thank you. Thank you very much, Magtriple. Nikto-H. Okay, so we'll figure out if... So Nikto's not... It usually doesn't get you anything, but I run it for fun. Because sometimes, especially if it's dealing with like older vulnerabilities, it does pick them up. But maybe not in this case. So the other thing we could investigate is the SMB ports. So there's... Oh. Nope. Okay, it's done. Alright, so the last thing we're going to do is we're going to run a more sophisticated directory busting program. In this case, it's called GoBuster. So GoBuster itself is not all that popular these days, but it's an older tool that I've been using for a long time. So we're going to run it on bank.nix. And we'll just leave this running in the background. I've got a feeling that there's nothing really important that we need to pay attention to on this website, but we'll just leave this scan running in the background. So what else are we going to do? I think I'll make a new tab. We'll call this SMB enumeration. And we'll give it a funky color. How about some green? Nothing but love for OJ. OJ? We're talking about GoBuster? OJ, okay. We're not talking about OJ Simpson. What distro is this? This is Kali Linux that we're doing right now. Okay, so there's I mean, the easiest thing we can do for SMB enumeration is a little tool called enum for Linux. I forget what the syntax is. Enum for Linux all, maybe? Bank.nix. Okay. OG maker of GoBuster. Oh, okay, the developer, yeah. Still good tool, only Ferrix kind of beats it for speed. I would not call him a dev. Oh, he's not called a dev? He's not a dev? Anyways, okay, so we tried using enum for Linux. We weren't able to... We were able to get anywhere? Got domain workgroup. Okay, server nix, bank.nix allows sessions using username. Oh, so it allows null sessions. So we got null sessions. Can't determine if host is part of a domain or part of a workgroup. Enum for Linux complete. SysOS Master says, OJ does cybersecurity work, used to stream too. Really? Huh. I mean, I'm interested in seeing who's in the live streaming scene for cybersecurity, of course. Okay, so the other big tool we can use for SMB enumeration is... what is it called again? netexec? NXC? And it's been so long since I used netexec that I don't actually remember how the commands go. So what's the syntax for netexec? So netexec SMB host, like, just a second, I need to take a look at my notes. I used to use this program all the time. Okay, so it's NXC and then the protocol SMB and then the IP address / domain, so bank.nix. So we'll try username blank and password blank. Okay, so null auth true, so we can access SMB with a null session. So null session means no username and password. So the next thing we try to do is we try to enumerate shares. Okay, so there are shares that we can enumerate on here. So there is a development share that we can read. And I guess another thing we could do is we could try to enumerate users before we take a look at this share. So we can do enumerate users. So we weren't able to get any users. And there's one more trick we can try to do to enumerate users. We could try the RID brute method. So RD, let's see, RPC lookup failed, RPC method not implemented. So we can't get usernames from the SMB protocol here. So what we're going to do instead is we're going to take a look at the development file share, because we were able to figure out that there is a development share. So I think the command we would use is like SMB client. It's been a while since I've used SMB client either. Tool training wheels. Tool training wheels? Hold on, I need to look in my notes for all these commands I used in the past. Okay, so this is what, I mean, this is the greatest example of why you should keep good notes. Because if I was not keeping good notes, I would not be able to figure out what the correct command syntax is for these commands. Okay, so we're looking at bank.nix. Comrade Soul, hello, nice to see you here. And we're looking at the development file share, and the port is default. And then anonymous login successful. Let's take a look at what's in here. So there's just a text file in here. So I'm hoping that there is something interesting we can enumerate from this text file. So let's go ahead and get that. So get this thing and then exit. It's getting a bit cluttered. Okay, so what do we see here? So it says here, subject AI agent integration. What? Why are we putting AI in our in our web applications? To streamline and accelerate the development of the banking platform, we've decided to integrate a subscription-based AI agent into the workflow. This service is proven to be cost-effective. However, please be aware that the AI may occasionally produce incorrect or unexpected outputs. For this reason, it is important to maintain strict attention to security and validate all critical operations. Cypher asks, "What is this?" So this is a CTF challenge. It's called Bank. Where is it? So it's over on Vulnyx. Yeah, I don't have a direct link over here, but if you want to download the VM and try it out yourself, here's the link. So it's supposed to be an easy level machine. 30 people have rooted this machine, and it's pretty new. So if we're able to finish this, we can consider ourselves to be in an exclusive club. All right, so let's see. A dedicated development directory has been enabled where developers can access and test the application. Directory. Okay, so this is security through obscurity. So we're given an endpoint over here. Additionally, the system administrator user called Juan, hired by Lucas in recent days, is currently on a probationary training period within the company. He will be responsible for completing the configuration of the SMB service. While the service is already installed, some final setup steps are still pending. Please note that he is still gaining experience, so we kindly ask for patience and encourage collaboration and assistance if needed to make sure that everything is properly configured. Best regards, Marcello. Or Marcello? He's going deep on the FED? Well, hope not. Okay, so we actually got quite a few good pieces of information here. So we know that this is the developer endpoint. So we're just going to navigate directly there. So bank.nix. And we're just going to wander on into the development directory. Okay, so we've got a login portal here. OJ Reeves, thank you very much, SysOS Master. Although I'm guessing that there's nothing really on his page anymore, since it's been quite a while since he's streamed. Username and password. I mean, we also got some good information from the note. It let us know the names of some users. So there's Juan, there's Marcello. So echo out Juan to users .txt, and there's also Marcello. And wasn't there's like one more name, Lucas. So Lucas is another name that we can put in here. And yeah, thanks for letting me know about these links, SysOS Master. I'll take a look at them after the stream is over. Okay, so we got 3 usernames. Juan, Marcello, and Lucas. So we also have a web form over here, so username and password. My guess is that what we need to do to access this is brute force the login page. So the username will cycle between these 3 names over here, Juan, Marcello, and Lucas, and we'll try every password we can in the big rocku.txt list. Okay, so how are we going to do this? Probably the easiest way to do this is to get the information for the login form from Burp Suite. So we'll just run Burp Suite really quick. The only thing we really want to do is we want to get the request, the post request that tries to log us in. And then from there, we can use a dedicated fuzzing program to try to do our brute force login. Let's see, proxy, open browser, and I just need to get the endpoint, put it into our Burp Suite browser. So I'll put the user in here and the password here. We'll try to log in. It says error, invalid credentials. That's fine. And then we're going to go over to Burp Suite and we'll take a look at the request. So this is the post request. We're going to right click on it and then we're going to select copy to file. So what that's going to do is it's going to copy all this information here from the web request into a file that we can feed into another program. So let's see, copy to file. We'll call this request.txt. Okay. And now we can feed this into another fuzzing program. So user and password. So username user and password pass, and login equals something something. So which program are we going to use? I mean, my favorite program to do fuzzing is FFUF. So we can do something like this. So request login.txt. But the other thing about this is that we also need to keep in mind that there are 3 users. So if there are 3 users, we probably want to use like another program, or we could use like a pitchfork. Let me try asking the AI. Maybe it can help me with the command syntax. Okay, so FFUF, we want to a login brute force attack for a CTF box, because sometimes if you don't tell it it's a pretend hacking scenario, then it gets upset at you. Login brute force attack for CTF box webpage. We'd like to use FFUF with a request, with a, what is it called? With a request file, a password list, and a users list. What would that command syntax look like? Where did my text go? Alright, let's reload the page, because apparently my text disappeared. Nope. It's back. Okay, for a CTF login form, the common FFUF pattern is to use a captured request with -request and run a cluster bomb attack with one word list mapped to user fuzz and the other mapped to pass fuzz. So the typical syntax would look like this. Okay. Now we just needed to wait for the thing to come back to us. Alright, let's take a look. Okay, so we got something like this. So passwords, we have users.txt in the current directory, but for passwords, we're going to be using the rocku list. So it's user share word lists rocku.txt. Okay, mode cluster bomb, I guess that is what we're looking for. Request proto, because we're dealing with HTTP and not HTTPS. Let's see. I think this is actually what we're looking for. So we'll just run this, and it looks like all the incorrect requests are giving back size 3084. So we're going to filter on this response size. So it's filter size 3084. And we'll just run this and see what comes back to us, if anything. So we can just leave this running in the background while we take a look at some other stuff. We're also... Are the passwords from the correct file? The password should be from user share word lists rocku.txt. So the users list is users.txt, which has three names in it. So there's Juan, Marcello, and Lucas. So this is a lot of requests, so we'll just leave this running in the background. So there was nothing in our fuzzing attack. So GoBuster wasn't able to do any directory busting. That's fine, because we So there's one more thing we could do. We could also do fuzzing on the SMB protocol. So this is, let's see, we're running it in the SMB, okay, enumeration tab. So we'll call this, what was it? FFUF brute forcing. And we'll make a new tab for SMB brute forcing. Okay. So FFUF is still running over here. This is going to take a while. So the other thing we could do is SMB enumeration. So netexec can also do brute forcing attacks. It's actually pretty slow, but netexec can do brute forcing attacks. I wonder if there's a better tool to do brute forcing with over SMB. I think Hydra can do it, and so Hydra can do it, and netexec can do it. I'm pretty sure FFUF can't do it. Let's try asking the AI. Okay, so what is the best tool for CTF brute forcing of the SMB protocol? So suggest a tool for me, please. Okay, for CTF style SMB brute forcing, the most widely used and practical tool is crackmapexec. Okay. Often combined with hash, cat, or John for offline hash attacks. So crackmapexec, I mean netexec is crackmapexec, but crackmapexec is the older name for it. So Hydra can also brute force SMB, but is less specialized. 3D Code Warrior, hello, nice to see you here. What is up? And welcome to the stream. You know what we haven't done in a while? We haven't done a fun video redeem. How about some Hack the Planet?
Hack the planet! Hack the planet! Shut up again!
Welcome to the stream. Okay, so I mean, if they're suggesting netexec, maybe we can try netexec, sure. NXC SMB protocol. The domain is bank.nix. Let's make this a little bit bigger. So for the username, we're going to use users.txt, and for the password, we're going to use user share wordless rocku.txt. So I'm pretty sure we can just do a brute forcing attack just like this. Oh, okay, we need to do ignore password decoding because there's some weird encoding stuff in rocku.txt. Okay, so this is going to run through the 3 usernames, Juan, Marcello, and Lucas, and it's going to run through all, I don't know how many million passwords are in rocku.txt. Actually, I can figure it out very quickly. So just word count, user share word lists rocku.txt. So this is 14 million, right? Yeah, 14 million passwords. -L for lines. So that is 14 million lines. Well, more than 14 million. Okay, so we've got 2 different brute forces running at the same time. So one over SMB and the other one running over HTTP. over here. So aside from that, we don't have very much to do. Because if we can't get in through the into the login page, customer access, username. The other thing we could check for is potential SQL injection on the login page. Invalid credentials. Okay, so if we do more, the box will break. I mean, the box breaks in different on different protocols. So the SMB service breaking is not going to affect the HTTP service breaking. Okay, so what else is going on here? So there's nothing in the source code for the login page that lets us know about hidden secrets. But the network might. We're hammering that thing right now. True. Okay, so the other thing we could look at, I suppose, is we could look at the at this particular request in Burp Suite, because it's what it's going to send back to us. There might be some interesting HTTP headers sent in response. Okay, I don't think so. Yeah, just invalid credentials here. So the other thing we could do here is we could limit the brute forcing attack to just one user. So the user, we're not going to look for all users. Instead, we're going to look for the one user, because we were told inside the note that the one user was in charge of setting up SMB. So if we limit it to just one user, that means that the brute force attack will go 3 times as fast. We've got ads running on Twitch right now, so when ads run on Twitch, we'll also take a little break and put on the birds. Okay, we'll be back in about 60 seconds. I just need to take a little water break. Okay. These guys are so fun to watch. Let's see, what else is in this clip? I think he's just chowing down. Yep. What's that? What are those noises? Man, those are some funny noises. Okay, anyways, back to the hacking. Bird names are hilarious. Bird names are hilarious. Some of them are. Okay, so we're just doing some SMB brute forcing here, and let's see. We're still not able to find anything solid on this login page. So I wonder if there's something extra we could check out. So there's port 180 open, port 139 open, port 445. We didn't find anything with... We didn't find anything with GoBuster. Oh, you know what we could do? So this is a directory, right? This is an endpoint, but we can fuzz inside of this directory as well. So this is what we would do. We could look inside of this directory, development blah blah blah, and look for additional directories or files as well. So let's do that. So this is index. Oh, there's an uploads directory. There's an admin.php directory. Okay, this is good stuff. Okay, so the uploads directory and the admin.php page also give redirects. So if we go back here, and we go to uploads, so this is an open directory. Well, no, it's not a directory, it's an endpoint. Admin.php page. But the uploads directory is open to anybody to look at. Not that there's anything here. Let's see. So admin.php. So this redirects us to, it redirects us back to index.php. Okay, so this is good. This is good. We'll wait to see if anything else juicy comes back to us. But let's see how the brute forcing is going. Oh, you know what? There's one name that we forgot to add to the list. We should have added admin to the user list. But we can go back and we can do another brute force attack later. Index.php uploads is just an empty directory. Okay. Day April says, you made me realize my definition of endpoint might be incomplete. I mean, I use the word endpoint to mean basically anything, right? Well, not basically anything, but yeah, that term used to confuse me. So let's see. Endpoint. What is it? So an endpoint is either a directory or a web page. So it's either a directory or a web page. So it could be /login or index.html. So these are both considered endpoints. So this is a login directory endpoint, and this is a web page endpoint. Dead end equals endpoint. That's correct. JSTN, hello, nice to see you here. What is up? Or Justin something something? I'm not too sure how to pronounce your name. Okay, logically, endpoint is a point where processing gets done for something. So a page, directory listing, REST interface, etc., etc. I mean, my definition of endpoint might not be completely accurate either. SMB is still running over here. Let's see. Haven't found anything new in fuzzing, or sorry, the directory busting. Haven't found correct credentials for the web app. I mean, the other thing we could do in this case, because we know that we're dealing with PHP application. So this is, was it index.php? Oops. So this is HTTP, this thing, index.php. Yeah, so this is index.php. We could try to scan this. We could try to fuzz this again for URL and what was it? What was it called? It's called local file inclusion. So if we wanted to fuzz this for local file inclusion, php.back. Nope. I mean, this would be another, like, big, loud fuzzing attack. I don't know how many of these big, loud fuzzing attacks I want to... Well, I mean, we've already got 2 web app attacks running at the same time. I don't know if adding a third is a good idea right now. Old school practice for backing up files for working live on the site. Yeah, I mean, it makes a lot of sense. So how many zeros are involved? 1, 2, 3, 4, 5, 6. Okay, this is this is going to take a really long time. Okay. So index.php, I mean, this might be vulnerable to local file inclusion, but it would be kind of a stretch, because there's nothing about index.php that indicates that it's interacting with other web pages or other files in general. This stream, more time? I mean, I'm not sure. So the other thing we could do is we could take a look at publicly accessible information. So for each one of these machines, they actually talk about what concepts are being addressed on them. So if we take a look at this machine, it's got the following tags. So SMB shares JWT. JWT, I haven't found the place in the application where there's JWT involved. We got bcrypt crack, we've got OTP bypass. OTP bypass, that's funny. File upload, Docker group. So file upload, we found a file upload endpoint. We just need to break into the web app first in order to find the file upload endpoint. So Docker group is probably the privilege escalation. I guess one more thing that we could do is we could take a closer look at the file that we downloaded. We downloaded a file called this txt file. Okay, let's go through this message one more time. AI agent integration and development environment setup. Streamline and accelerate the development of the banking platform, we've decided to integrate a subscription-based AI agent into the workflow. This service has proven to be cost-effective. However, please be aware that the AI may occasionally produce incorrect or unexpected outputs. For this reason, it is important to maintain strict attention to security and validate all critical operations. A dedicated development directory has been enabled where developers can access and test the application. Okay, so we're currently trying to break into the development endpoint over here. SysOS Master says, does the administrator use JWT, maybe without encryption? I mean, we'd have to figure out how to log in first. Amen, hello, nice to see you here, what is up? So for the FFUF brute forcing, I think what we need to do is we need to not pay attention to the users list, but instead we should just try to focus on breaking into the administrator user's account. So let's go back into request.txt, and we'll just put in admin as the user instead. So we're not using the user's word list anymore. And we're not using the cluster bomb mode anymore. Whoa, why is this going so slow? We're suddenly only doing like 2 requests a second. Okay, SMB isn't fully configured. I think that might be a hint. Okay, So additionally, the system administrator is called Juan. The system administrator is called Juan, hired by Lucas in recent days. Currently on probationary training period within the company. So Juan is potentially like the SMB user. Give it a minute, you were hammering it, yeah. Okay, so... yeah, this is going real slow now. Username admin and password pass and login equals something something. Oh, it's producing a bunch of errors now. Hold on. Let me adjust the request file. So we'll go in here and we will put the fuzzing point here. Okay, hopefully we don't get a bunch of errors this time. So the other message was talking about how SMB isn't completed. The configuration for SMB isn't finished. So what are some SMB misconfigurations? Let's do a quick query to our good friend the AI. What are common SMB misconfigurations that can affect security? Permissions, guest access. Yeah, I mean, we've been taking advantage of this stuff already. Shares exposed to everyone are authenticated users with full or modify rights. So C, admin, custom data shares. Misconfigured home or department shares. Null sessions and anonymous access. So allowing null connections or legacy lets attackers enumerate shares, users, and groups without credentials. This enumeration fuels password spray and brute force attacks. Weak are legacy authentication. Guest or convenience user accounts. So guest accounts. So the C share, the admin share. Misconfigured SMB version and encryption. Poor logging and monitoring. Open for file share. Oh, you know what? I think we might be able to do a file upload attack if we could access the... Actually, you know what? Let's try getting in there one more time. So SMB Pamian, we're just gonna stop doing our attack here. So SMB client, actually let's check the history. No, it's not here. Alright, I need to get my SMB client command again. So, what was the name of that? Was it like documentation or was it configuration? Bank.nix. Documentation? Bad network name. So it wasn't documentation, it was like configuration? Enum for Linux. Hold on. Let's run the netexec thing again. Okay, so it's called development. Okay, never mind. Oh, there's also like a nobody share, but we don't have permissions over that. Okay, let's try the nobody share first. Access denied. Okay, so access denied for nobody. What about development? So there's just this file here. The current directory is bank.nix development. So can we escape this? No, we can't escape this. Okay, development, you do have some permissions. So our permissions here are, it should be just read access, or at least that's what is reported. Mohammed, hello, nice to see you here. What is up? We've got these commands right here. Another thing we could do is we could run a bunch of common scripts on the SMB protocol. So we could do, let's see if I can search it up. So let's see, nmap smb vuln scripts. Enumerating SMB with nmap, okay. Alright, let's hope that it has some command syntax for us. Yeah, it does. Okay, great. Okay, so SMB enum, let's just run all of the SMB enum scripts. And we'll run it verbose. Script execution failed. Okay, so we'll do SMB vuln instead of SMB enum. And let's see what else we found. Well, we didn't find any vulnerabilities here. Yeah, we're not able to... Actually, you know what? Add an empty username and password for Username and... Oh, okay. Maybe. Just a second. I want to get a new request for this. So we'll do username admin and password fuzz. Let's see, copy to file. We'll call this request2, or just login .txt, and we'll feed this into FFUF. Yeah, this is not great. There's something wrong with my... There's got to be something wrong with my command syntax. Okay, is there something wrong with my FFUF command syntax? I'm getting nothing but errors. Okay, your command is missing a required target URL and fuzz placeholder. So FFUF doesn't know what to fuzz. Your existing line has request login.txt, write HTTP request from a file. Okay, request proto HTTP protocol.request, w word list, but no target URL and no fuzz keyword in the requester URL, so FFUF throws errors. Keyword defined but not found. Oh. Okay, the minimal correct form is this. So rocky.txt fuzz. Okay, let me give that a shot. Okay, so this, yeah, that was it. I just need to filter on size. So we're gonna filter on size 3084 again. Okay, so we're running the thing now and we're not getting errors. That's good. SMB enumeration still going over here. So there's still only one file. So we're keeping close tabs on our login brute force over here. Looks like we finished. We finished our other brute force for directory busting. What I really should do when I run this thing, so I should probably redirect this into a file, so like something like gobuster.txt or gobuster1.txt. Just leave this running in the background. We got it. So the user, so the admin password is Blink182. So I guess this guy is a fan of like 90s bands. Sure. All right, let's log in. We got it. Okay, so admin Blink182. Log in. Okay, this is taking its sweet time logging us in. So we can stop this attack because we've got our password. Let me just copy this just to make sure I didn't. So this one, I'm not gonna lie, at the time I totally rocked 182. No shade if you did. It was pretty fun music. Huh. Why are we stuck? Hold on, let's try this one. Admin. Okay, so now we have to deal with the OTP. So security verification OTP, a verification code has been sent to the account associated with the administrator. Please use the 2FA code. So the 2FA code, it could be that the 2FA code, well, it might be in a cookie. If it's in a cookie and it's in the cookie, like what we did earlier today, then that would be really funny. I mean, we do have a cookie here, auth token. So what is this? Is this Flask? Or is this... No, this is JWT. This is JWT because, yeah, okay. So what we can do... Go back here. jwt.io. This is an application where we can try to find out what's in here. So JWT decoder. Paste in our thing. Okay, so it's just JWT and then ALG HS256. So decoded payload, there's no... Ha ha ha! They've got an OTP in here. 444038. 444038. Okay, go back. Verify access. Wow, we're in the money. Listen, guys, we've successfully broken into the bank and now we're rich. That was, you know what? This was the same kind of vulnerability we found earlier today. So the two-factor OTP was contained in the cookie. I don't know if this is like a standard vulnerability that you see a lot, but it's pretty, well, it seems really dumb. It seems really dumb when you're just looking at it like this. Okay, well, anyways. Okay, send wire transfer. Sure. Send all the money to me, please. All right, savings account, classic, bank alpha. We have our admin panel over here. We can create new users. Return to dashboard, admin session active, okay. People abuse JWTs for all sorts of things. Yeah, I mean, we've talked about a few different JWT attacks over the years. Internal administration tools, so I want to find, so there's temporary password, username. I want to find the part of the application that lets us upload files. I am on YouTube. Mohammed, hello, nice to see you here. So register customer. Alright. Let's try... Oh, we've got a timeout here. Okay, we'll try to log in as the administrator here. Admin. Blink 182. For some reason... So, okay, we need to do the 2FA code again. This was recorded by Burp Suite. Let's go back. Proxy. Post. And this is where we got our authorization token. So let's just log in with the Burp Suite browser. Okay, so the OTP is different now, so let's just copy that and we will log in. Okay, what we want to do here is we want to figure out if there's some way we can upload a file. So send wire transfer, page equals dashboard, we can look at, I don't know, page equals ... / a bunch of times and then etc password. Okay, that didn't work. Lost the stream on YouTube. Dang it. When was the last error? Never mind, it came back. Yeah, so the last error happened at 6:50, yeah, like a minute ago. Sorry about this, guys. I really need to do some diagnostics. Went down for like 2 minutes. Yeah. I'm sorry about that, everybody. Okay, so my account. Oh, my account. We can update it. We can upload a photo. Okay. So if we can upload a photo here, we could probably do some PHP shenanigans because this is a PHP application. Okay, the OTP security system is reserved for administrative accounts, coming soon for standard users. Sure. Okay, we got all the money. We can update our password. Don't know if we'd want to, of course. So update photo admin. Well, I mean, the other thing we could do is we could try to log in to SMB as one. With Blink 182. So one. Hidden field for account to update. Xmetric, hello, nice to see you here. Update the admin password. Up that to. Okay, so this is not Juan's password. I'm going to try the other users as well. So Lucas. We're just checking for password reuse. The last user is Marcello. Okay. Admin, maybe. Or administrator. Okay, that's not it. Alright, we can go back to the file upload angle over here. So update photo admin, no file chosen. And we'll try uploading anything, right? So we got a text file here, upload file. Invalid file type, only JPEG, PNG, and GIF are allowed, so it's pretty standard. So we need to smuggle in. Actually, we don't necessarily need to smuggle in. We need to take a look at how this request was processed. Is there a files type restriction? Is there a client-side validation? I mean, we'll figure it out over here. So we sent a post request to page profile over here. Let's put this in the repeater. Ooh, what happened? Oh, I detached the repeater. Wait, how do I get the repeater again? View repeater, okay. Oh, I took it off the dock. Can I put it back on the dock? Okay, we can. Awesome. Okay, so what's going on here? So let's see. Let's go back. Proxy, post page profile. Put this in the repeater. Okay, name avatar file login.txt. Content type text plain. So content type, we might be able to upload it if we modify content type. So let's see. Content type JPEG file. What is it called? Like image slash JPEG. So we'll just sub this in. Image PNG, yeah, something like that. Okay, and we'll try this. Internal server error. Okay, it didn't like that. So text plain gives us a response of 200 OK, but it gives us an error message. Image slash PNG. Yeah, maybe I can try image slash PNG. PW equals fuzz. Where did we see that? Oh. I mean, it looks like this is unauthenticated. Check uploads too. Yeah, internal server error. So we know that there's an uploads endpoint. We could try checking it out to see if it actually got put in there. Probably not, but... Oh! Hold on, it actually does get uploaded. It did get uploaded. Okay, but we have to take a break, because there's something... Alright, so while the ads are running on Twitch, let's put on the birds. And I think... Where does the bird show up? Here we go. Okay, we'll be back in about 50 seconds. Okay, that's like some neighbor kids. They just happen to be the background noise for the clip. But let's see if this is... Yeah, he's having a good old bath. Anyways, I could watch these guys all day, but we need to get back to the hacking. Okay, so it looks like it does upload. So if it does upload, we just need to create like a reverse, like a web shell. We just need to create a web shell. So we're just going to get our web shell from revshells.com. And where's our web shell command? So it's like PHP command small, this one right here. Drop PHP web shell. Yeah, well, we'll do our best. Okay, so it's shell.php. and we'll try uploading this. Where are we? Here? Okay. So choose file, shell.php, select upload file, and then we get the error message, but it didn't actually get uploaded. No. Okay, we see it's not uploaded here, but let's just try modifying the content type. So we'll go back, proxy HTTPS tree. This one. And then we'll modify content type image JPEG. Did that work? Yeah, that didn't upload. We need to bypass the MIME type. Okay, so I guess what we'd have to do here is we need to figure out what the magic bytes are for JPEG files. I mean, the easiest way to do this is to upload like a legitimate JPEG file first. So let's get a legitimate JPEG file. Fine. Let's see, locate. So we've got some legitimate example JPEG files over here. I'm just going to grab this 1x1 pixel one. Copy to current directory. And then we'll try uploading example11.jpg. Upload it. The page isn't working. Unable to handle the request. Why? Choose this file. Huh. It doesn't want to upload this. I mean, it might be the name of the file. Maybe we need to rename the file. So we'll rename this to test.jpg instead. And we'll try it, see if it goes through. There it is. Okay. Yeah, it doesn't want to. It doesn't want to upload this. Let's try like a JPEG file then. So we've got, or like a PNG file. So we've got a PNG file here. Try testing everything. I mean, we're working on it. So we'll choose the file, the PNG one, upload. Huh. We get an error. That's weird. The file's uploaded, but we get an error message. So they get an error message when it successfully uploads. So let's try sneaking it in then. Okay. So proxy. This is the one for example PNG. Okay, this thing. All right, we will put this in the repeater. It is a development site, that's true, so stuff is broken, huh? Alright. So we'll call this image PNG content type. That's fine. The content, we're going to put in our shell.php code into there. So let me just copy this. We're just going to delete everything before the magic bytes. Yeah, we also need to change the file name. And when you're dealing with modifying these payloads, it's very useful to output the raw bytes over here, and as well as the... Okay. So we've got our payload in here. So image PNG. File name is, we're going to rename this to shell.php or webshell.php. And I think this should work. Okay, we'll send it. We get 500 internal server error, which means it probably uploaded. So if it uploaded, we should see it in here, webshell.php. Okay, so it seems like it works. So we're just gonna give this 0 equals who am I. And we've got remote code execution. Okay, from here, all we need to do is upload a binary, and then execute the binary to give us a reverse shell. So, I'm gonna go to remote access. We're gonna run Penelope on port 443. So Penelope is our ID. The ID is probably gonna be www data. Yeah, this is www data. And we've got our standard groups for www data, which means no special permissions. Okay, so before we upload this, we're gonna have to set up a little server for ourselves. But before that, we're gonna do, what is it called? We're gonna create a reverse shell binary. And we're gonna figure out what our IP address is. So our IP address to M server on port 80, and we're just going to run our wget command. We're going to get our rev.elf. Twitch was dead again. Yeah, I need to... I've been having problems for the last like 4 streams. Okay, so we'll run this command from the web app. And we'll see if it runs. We'll see if we get access. So local services here. So yeah, it did download rev.elf. Then we need to chmod it. And then we need to run chmod.elf. We need to run rev.elf. And it looks like we got access. Who am I? We're www data. Supreme Overlord, hello, nice to see you here. What is up? What is up? Okay, so we just got access to this machine. And I guess we can call in Mr. Scary Hacker Voice Man to talk about this. Let's think about how we got access to this machine. Just a second. Okay, so because it was pretty long. So how do we get in? So step one. Step one. Figure out there was a SMB null sessions enabled. Step 2, download a text document. Found info on SMB, correct, yeah. So found a text document with a hidden endpoint on the web server. Step 3, brute force the admin user's credentials for the web app. For the, brute force the admin user's credentials. Step 4, go busted. Oh yeah, right. We did need to use some go buster. Directory bust and find the /uploads endpoint. Step 5. Oh, JWT for OTP. That's correct. So brute force the admin user's credentials. This is 4. This is 5. This is 6. Let's see. Bypass the OTP function by decoding the JWT session cookie. Okay, directory bus and find the /uploads endpoint. Step 6, use the user avatar upload function. And bypass the file extension filter to upload a web shell. Upload malicious reverse shell binary and execute it. Initial access. So, yeah, how much time did we spend? We spent like 90 minutes getting here, huh? So I put 2 hours on the clock, and we've got 24 left. And it took us 90 minutes to get us our initial access to this box. Anyways, let's call in Mr. Scary Hacker Voice Man to talk about exactly how he got in, because it's fun to call in Mr. Scary Hacker Voice Man. Just a second, everybody.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into a server, and we just broke into this one. Well, Mr. Bank Administrator, it seems like you enjoy setting up SMB file shares with null sessions. That is a big mistake. We were able to find your hidden login page, and then bypass the file extension filter to upload a web shell, which we then use to upload a reverse binary. Reverse shell binary, that's what it's called. Maybe you knew about these security flaws on your system, or maybe you decided to accept the risk. Well, you accepted the risk, and now we're in.
Okay, reverse binary. Well, I mean, that's a binary that you run the reverse shell. Well, that's a binary where you run the reverse shell on, right? So I'll show you. This is a reverse binary. So if you've got bin bash, you can cat bin bash and it looks like this. But if you run rev on bin bash, then you've got reverse shell binary. Huh. I guess we'd need to pipe it into rev. Oh, rev doesn't work. Funny, funny, funny. Anyways. Alright, we've got initial access now. Okay, Swir Alligator. Hello, nice to see you here. I like your stream so much, so chilling. Wow. Thank you very much for the compliment. Alright, so... what do we do from here? Well, let's make this a little bit smaller. The var www bank development. Var www bank development, huh? I wonder what's in the var directory base. There might be some credentials lying around the lying around here as well. So there's admin.php, index.php. Let's take a look at these PHP files. So the actual PHP in the code should be up at the top. Yeah, okay. Oh, interesting. So username bank, password bank1432. So we got a password for the database here. And the JWT secret is your secret key 182. Blink 182 shows up again. Well, I mean, I guess they're internally consistent. Alright, we've got another password here as well. So bank1432. So we can put this in our list of passwords. Oh, where are we? Okay, so our passwords include bank1432, and we also have blink 182. Okay, and what else? I always hope there would be a live stream that I really enjoy. Hello, Kiwi. Nice to see you here. And hope you're having a good day. Okay, so the bank database might actually have some more information in there. Okay, JWT stuff. Is admin. Okay, and oh, Penelope's so nice. This shell is so good. All right, so that's the development directory. There's also like the admin.php. Huh. There's no command history though. I guess that's one kind of limitation to Penelope then, huh? So this was index.php. Let's take a look and see if there's anything for admin.php. Yeah, we've been having disconnection issues. Let me take a look at what's going on in my OBS. Yeah, the keyframes and the bitrate seem to be okay. I wonder what's actually going on here. Okay, so let's take a look at the PHP code. So this is the same stuff. So we got localhost, database, bankdb. We could probably figure it out. Is there netstat on this box? There's no netstat. Is there SS? Okay, there is SS, so there's probably some sort of database running in the background. So SS Tulpen. So there's... What's all this UDP stuff? TCP 3306. Okay, so there's MySQL. Well, probably MySQL running on 3306, which we could access. There's another thing that's listening on port 37,000. Second of mind, hello, nice to see you here. How goes the bank hack? We've got initial access. We just need to figure out the privilege escalation for this thing. So there's 3306. We probably want to take a look at never left, been lurking. Oh, really? Okay. Well, welcome to chat then. Welcome to chat. Okay, so let's do the local access. So let's see. MySQL. What is the format of that command? So the MySQL local access type command. So let me see if I can find it in my notes. MySQL. Okay, I think I've got it. So something that looks like... So MySQL we can access with the bank user. And the password would be the one that we found. Okay, Second of Mind says I was reconciling my notes from the HTTP business CTF this past 7 days. Oh, you did a Hack the Box business CTF? Was really tough, only got like 18k points. I mean, where were you in the leaderboards? I'm sure you were much higher in the leaderboards than most other people. Okay, what was that password? This one. Enter password. bankdb information schema MySQL. So I think we want use bankdb. Okay, database changed. Now we can... MySQL doesn't like spaces for some reason. Okay. And then we do show tables. We got transfers and users. Okay, well, select star from transfers. Nothing exists. So there's nothing in transfers. We're back. Oh, did we do another disconnect? I hate this. I'm gonna have to look into my stream health and my analytics for YouTube after this. Thought my PC died for a sec. No, it's on my end. Okay, select star from users. Okay, we've got one admin user. I mean, we know this admin user's password, so this doesn't really help us very much. Yeah, says the stream's been like this for the last like 3 streams. I really need to... Okay, so accessing the database isn't really helping us. Let's just exit out of here. So what other users? Okay, so there is a MySQL user, there's a Juan user, and there's a Lucas user. So the Lucas user, the Juan user, might be using the same password. So the password is bank1432. So SU Juan. No, this is not Juan's password. Is this Lucas's password? This is not Lucas's password either. Could it be Root's password? That'd be really weird. No, it's not. Someone said Twitch is testing something. It's not, it's probably not Twitch, because it's occurring over both YouTube and Twitch for me, so it's probably on my end. Oh, there's also a Marcello user. Okay, so try switching over to Marcello. No, it's not that either. Okay, we've got one more password we could try for all these users. And that's the Blink182 password. I really hoped it was going to be password reuse. Oh well. Okay, so Marcello. And Lucas. Likely the restream or multi-stream platform. I guess we'll, yeah, I'll investigate it later. Okay, it's, yeah, so these are not reusing passwords. So we got our uploads, we've got our admin.php, index.php. We've got our special directory, and then we've got our index.html. That's not going to lead anywhere. So there's bank and HTML. We were in bank. The regular index.html doesn't really have anything here. Yeah, okay, this is the Debian default page. Sudo L? I mean, it's unlikely, but I'll give it a try. And we need a password for this. Blink 182. And what was that other one? That was like bank something something. Okay, so that wasn't it. So there's also the possibility of, like, what are they called again? SUID binaries. So we would do find / perm -4000. Okay, what do we got? So none of this seems like super out of the ordinary. Mount, umount, gpassword, new group. This all seems very familiar. So probably not this. Is there anything in the op directory? Is there anything in the temp directory? Is there anything in the... So the root directory, what do we got? So this is not drop linps. I mean, when we run out of things to do, you will certainly drop linps. I want to muck around a little bit in the home directory. So there's Juan, Lucas, and Marcello. So if we metagame this, okay, we've got ads running on Twitch. Okay, ads run on Twitch. We'll put on the birds. Where are they? My favorite video. Okay, this will help us get some momentum. We'll be back in about 30 seconds, but enjoy the birds. Okay, so Limpy's fat. Let me get my IP address so that I can download it. With blackjack and hookers? Yeah, of course. wget from our server linpeas.fat underscore fat.sh like this. Yeah. Okay, and then we can download the thing. We'll just put it in like /temp. Okay, so it's here. So we can just run it. chmod plus x, limpeas, fat, and then run the thing. Okay, let's go ahead and pay attention. So reading linp's output is in art. We want to figure out what to pay attention to and what to ignore. So pseudo version, this thing. Probably not the intended thing. Okay, so let's see. User disks. It's not running super fast. Just wait for this to come back. Okay. Let's see. Containers. User bin Docker. Container related tools present, if any. This is taking its sweet time to run. Why is this taking such a long time? Okay, I think let's think about how much more time we're going to be spending on this. I think I can do another 30 minutes or so before I need to get going. Oh wow, it came back to us all at once. So I'm going to put another 30 minutes on the clock and see if we can get ourselves root in that time. Hopefully. Okay, let's go back to where we were. Here we were, yeah, I think we were here. Okay, cloud. Running processes. So another thing I should have paid attention to before I started running linps was cron jobs, if there are any cron jobs running. Okay, Brave Traveler, hello. Are we hacking eCorp Bank? Oh man, if only. We're giving it a shot. Cron F. Cron F, huh? Maybe there is a cron drop running on this box. Growing deep on the Fed. And as me, hello, nice to see you here. What are you doing? So we're just doing we're doing a hacking exercise. There's a simulated bank that we're trying to hack into. Well, the server anyways. What is this command? Import base64 zlib execute something? There's some sort of long-running... Oh, you know what? This might be Penelope. That's interesting. That's, yeah, probably my reverse shell. Okay, so we got Apache 2, MySQL, Docker. There is some sort of Docker running. Okay, processes with unusual configurations. MySQL process found, Apache 2 process found. Opened files by processes. So we've got Okay, you will know, let's see. If a user can somehow spawn processes as a different user, so this process is run by user root, by the PAP user is DHCP. Okay, that's normal. Where do you learn this stuff? Yeah, I mean, if you want to learn about hacking and information security and stuff, we've got a fun thread over on Reddit called Get Into Cyber. You might want to take a look over there. Okay, so cron job list. There's something called PHP that's being run. So placeholder, E2 scrub all, popularity contest, PHP, and what is this thing? Duck, hello, nice to see you here. What is up? Checking for specific cron job vulnerabilities, checking these things. An old PHP old session scrubber. And what is this? Unix sockets analysis. Socket analysis. I've never been able to use sockets as a method of privilege escalation before. PHP like one in HTML? Not exactly sure. I think Hack the Box labs are extremely difficult. Hack the Box labs are extremely difficult. I mean, the average difficulty of Hack the Box machines is higher than on some other platforms. So yeah. Okay. So dbus analysis. Network information. We got bank.bank.next. Okay. What these listening ports. We know about everything but the service that's running on this port. So this is a weird port. And I think I might be investigating this afterwards. Alright, so what else? Users information. Where the have you tried netcat on the port? Yeah, we'll be doing that next. So sudo protection, sudo tokens. Okay. Polkit. Users with UID 0. Okay, so there's root only. Users with console. So there's Juan, Lucas, and Marcello. all users and groups. So Marcello is part of the video group, and Marcello is also part of the Docker group. So I think we have to find some way to become the Marcello user. And then maybe from there, we need to do like a Docker escape or something, or like a Docker privilege escalation. Okay, TMUX sessions, software. Meridi, you might be able to escalate privileges with this. So run. I have no idea what run C is. I mean, let me grab this link. Has anybody here heard of run C before? Let me know if you have. Okay, password files. SSH configuration was found, okay. Run C is part of how Docker works. Oh, okay. Oh, if it's part of how Docker works, it might be the method of privilege escalation. Files with interesting permissions. Okay, so I'm pretty sure we're getting close to the end. Unexpected en route. Files with potentially weak permissions. So this is a log file. var backups. Backup files. Searching passwords in history files. Okay. Searching password or credentials. Checking all environment variables. Okay, regexes and search whatever. Okay. Alright, so run C privilege escalation. We'll take a look at that next. But there was a specific port number running on this thing. So we'll run netcat, localhost. What is this service? Bad request. Bad requests? Is this a web page? Moved permanently. This document is moved. So there's a web server running on port 37485. Try curl? Yeah. Okay, let's curl this with some verbose. So this is moved permanently. Network is unreachable. Network is unreachable. Moved permanently. Oh, how do we follow redirects with curl? Curl follow redirects. Dash capital L. Okay, yeah. Curl VV cache capital L localhost. Localhost 37485. Connection refused. Let's try HTTP. "404 not found." What are you talking about, Duck? Okay, so curl, no. Netcat. So this port is HTTP1 bad request. So this is bad request. So if we do I wonder what kind of web page is running up there. Because this comes back as HTTP. So HTTP bad request. I wonder why we couldn't use curl then. Curl HTTP localhost on port 37485. Page not found. So this is 404. What if we... Well, here's the thing. This website has to be... The pages for this website have to be on this... have to be on the server. So they... Is it like... index.html? Nope. Yeah, that's a good idea. Second to mine. I can just I can use netcat to do this. Bad request. We're missing required host header. Okay, so we need to supply a host header. So we run the same thing, and then we just include a host header then. Host localhost. Yeah, okay, I see. Okay, now we get 404 not found. Or we could use HTTP 1.0. Could we? Yeah, it doesn't like this. Content link 19, 404 not found. I wonder if we could do some tunneling or something. So... or local port forwarding? The thing is that we, I mean, we don't have like a valid SSH. It's really weird that this port is open. Okay, so to cheat a little bit, let's take a look at the tags associated with this. No. Let's take a look at the run C thing. Okay, privilege escalation via library. Can we read the Apache 2 config? What directory is that in? Is it the etc? Apache 2, Apache 2.conf or something like that? Yeah, okay. It's a pretty big file. So this would let us know about different paths. Include lists of ports to listen on. Include ports.conf. Ports.conf. This probably has a reference to the weird arbitrary port we're looking at. That port number should be somewhere, yeah. Okay, so let's find the file. Find /name ports.conf 2dev null this thing. Okay, so it's etc apache 2 ports.conf. So if let's go ahead and read that. Okay, Brave Traveler, thank you for the frog hype, thank you. Get a file share on there, no? Oh, maybe. So listen 80. So it just says listen 80 here. From the port scan? Yeah. Well, I mean, the port scan only picked up the standard ports. So, well, the ports that were open to all interfaces. Let me see if I can search this up on Hacktricks. So I hate searching on Hacktricks now. Is it run C? No, that's it. Search. Okay, container security, runtimes, and engines, run C. Check the Samba config. Check for the Samba config. So would that be like samba.conf? Find name samba.conf. / etc samba. Etc samba, okay. Just wondering if all the passwords now gave you access to something new on that file share. You got it on in the background. Okay, so let's do cd etc samba. Okay, smb.conf. Okay, so let's take a look here. Browsable, yes. Read-only, yes. Guest, okay, no. Guest, okay, no. Home directories, browsable, no. Template shell, bin bash. Domains. And password change. Interfaces 127.0.0, whatever. Nothing super... I don't think there's anything super useful here. Gave you the mounted share, did it? Okay, path service SMB share. Server SMB share. Server SMB share. Oh, okay. So this is the... yeah, so this is the share that we found before. It's owned by Marcello. And we read this. Yeah. Let's navigate directly here. So SRV, SMB. Share and passwords. What is this passwords directory? Surely there are not actual passwords in here. That would be... Why is there a note from Juan? The KeyPass password is this. Thank you. Thank you for letting us know about that, Juan. Deleted after reading, but don't worry, I think I've configured this directory properly, so only you can access it, and that's not supposed to expose the SMB service either. It's a KeyPass XC file. Alright, so, we got a KeyPass password. Hey, as you've said, Marcello, I've already left a KeyPass file with all the system passwords you asked me to create except for the root password. The KeyPass password is this. Okay, so let's just copy the KeyPass password and we'll put it in, I don't know. Ooh, this... yeah, we're gonna have to turn on the text editor for this. Okay, download extract GG, hopefully. Okay, so the KeyPass password is here, deleted after reading, but don't worry, blah blah blah. So passwords got KDBX. So we can read this, and we can make our own copy. So cat passwords.kdbx, pipe it into base 64. Okay. So we can copy this over to our local machine, and then we can start mucking around with that. Nano KeyPass, well, B64. Paste this in, and then cat B64 file. Oh, well, pipe it into base64 decode. And output to KeyPass dot, what is it? KDBX? Is that the graphics version of KeyPass on Linux? I'm not sure. It's been a while since I've interacted with any KeyPass stuff. KDBX, okay. Passwords.kdbx. Where to put it? KeyPass XC. I don't remember if I've got a KeyPass program installed on this machine or not. So KeyPass password database 2.x. Okay, and KeyPass not found. Do we mean KeyPass 2? KeyPass XC looks like it's part of Kali's native repo. Oh, really? key pass XC. Key pass XC. One word. Key pass XC. Okay, key pass XC full or key pass XC minimal. So I mean, we'll try installing it. Why not? Okay, and then, ooh, are we not able to access the servers? It might be because my minimal is broken by design. Apt-get. Oh, right. We should probably update this first. So apt update. Okay, and let's see if this actually installs. Looks like it's working. Okay, so what's the command? Key pass XC. Okay, we've got a program. It's well, create database, open database, import file. So open database. We'll open. Where'd I put it? Temp, what is it? HackerFrogs, KeyPass, KDPX. Enter password. So they want the password now. Let me get the password. It's this thing. Okay, it works. Great. Okay, so we've got one for Juan, one for Lucas, and one for Marcello. Hey, parts people. Parts people? Just rated the channel with 51 viewers. Hello. Hello, everybody. My name's the Shy Hat. We're currently hacking stuff. We're hacking a challenge called the Bank on Vulnyx. It's been a heck of a ride. We've been doing all sorts of wacky attacks, like JSON web token decrypting, and what is it called? 2FA bypass, and file upload attacks, and now we've been stealing people's KeyPass database files and stuff like that. Okay, Twitch is not nice today. The stream drops for a moment. Yeah, so the stream does drop every so often, unfortunately. But welcome in, Raiders. My name's the Shy Hat. I do cybersecurity stuff on Twitch and on YouTube. But unfortunately, it seems like my streaming setup is a bit messed up. So we'll give ourselves another 20 minutes to solve this challenge. Okay, so we got them. But hey, parts people, what were you doing on stream? And Raiders, let us know what parts people was doing on stream. I'm not familiar with parts people. Mr. Poolshot, hello, nice to see you here. Okay, so password. Okay, we got Marcello's password. Let's copy this. So Marcello is part of the Docker group, and I think did I not copy it correctly? Copy. So copy Marcello's password. Marcello. Am I spelling this name correctly? Okay, we're now the Marcello user. Okay, are the mods bots or people locked in a room? Are the mods bots or people locked in a room? I don't think they're locked. Control C copies it. You should use minus. Okay, so we're Marcello now. So let's march on into Marcello's home directory here. We've got SQLite history dev null user.txt. So this is the flag. There's a .local file here. And so this user is part of the Docker group. So we might have to, you might still have the www environment variables. Could we? No, I mean, we're Marcello now. At Pikachu, what are you guys doing today? So we're hacking a bank hacking scenario. So it's not exactly a real bank, but it is a virtual bank, I suppose. And it's found over here at the Vulnyx website, where you can download a virtual machine and then do some hacking against it until you get super user access, hopefully. Okay, so we do have our Docker group. So we need to find, I mean, this is not a Docker. What can we do with this Docker group? So bash history, what's the .local? .local share nano. Claretto, hello, nice to see you here. What is up? It's a mock bank. It's not a real bank. It's a simulated bank. All right, so .local. MySQL history profile. Well, let's read user.txt just for fun. Okay, so that's nothing really interesting. I mean, we're not stealing any real money over here. So one interesting thing we might do. So if we're part of the Docker group, what is a common privilege escalation vector we could use? Let's do a quick search. So let's see, Linux, okay, Docker group privilege escalation. Just mount the root file system. Mount the root file system? Oh, that's interesting. I don't think I've done that before. Okay. Members of the Docker group can easily escalate privileges to root on the host machine because the Docker daemon runs with root privileges. Any user in the Docker group can spin up a container that mounts the host's root file system. So exactly what Sick in the Mind was talking about. So like docker run v mount might be Norse switches. Well, let's give it a try. Okay, so mounting the host. Example exploit command. A member of the Docker group can execute the following command to spin up an Ubuntu container, map it to the host root directory, to a mount host folder on the container, and then immediately drop into a shell. From the mounted shell, the attacker acts as root for the entire host system. Oh, okay. I mean, let's give this a try. Let's see. Please later drop the GitHub links for the summary of the commands used. Yeah, I mean, I'll probably do a write-up for this after I'm done. Okay, so let's give it a try. So just run this. Unable to find image Ubuntu latest. So I mean, we can't download this. So first check what images are available. Docker images. Docker images. So there's a Debian Unable to find image Debian latest locally. Can also use, the one I see the most is Alpine. So we got Debian over here. There's got to be something like, oh, you use Debian Bookworm Slim with this tag. Okay, okay. That's not what I wanted to do. So it would be Bookworm Slim and Debian. Who am I? I'm root. Wow. Now I'm root. Alright, I mean... root on the Docker, yes. Okay, so I think,
What are you?
I'm system root.
okay, so you can crack the root password now. We can crack the root password. Can we? Let's move into the root directory first. So there's root.txt here. So I mean, we've got access to root.txt and we can read it. Cat root.txt to iRead root.txt. Wait, what do you mean there's no root.txt? I didn't move into the directory. Okay, so cat root.txt into iRead root.txt. And now iRead root.txt exists, which means we've successfully accessed the root flag. What's the progress status? I mean, we're pretty much done. Let's see. It's important this root environment is only on the Docker. You're on the wrong file system. Are we on the wrong file system? We're in the root directory. You mounted root to... oh, the mount directory. I mean, there's no... Yeah, we're root on the Docker image. Actually, let's take a look at the home directories. So this is the host. This is the host file system. We've got our Marcello user, we've got our Lucas user, we've got our Juan user. If this was like a separate image, then we wouldn't be able to see this. df-h. Whoops. Yeah. And I think we're good. We've hacked a bank, kind of. We kind of hacked a bank. 10 minutes left. Okay. Please send me some money, yeah. Let's read the etc shadow file. Thank you very much for subscribing on YouTube. Kakaroto15, thank you. Okay, we've got our root password. I mean, most of the time the root password is not really something that we could read with We're in chroot, so it's all fine. Steal $5 from me. Okay, the easy fix is just to plug in SSH public key into authorized keys. Should I uninstall Windows and use Kali Linux daily? If you want to. Or you can just SSH-I to have a real root shell in the box. I mean... So, are these changes permanent? So I'm running inside of a Docker container of the local instance. So if I create anything or make any adjustments to the file system, do they persist, or are they going to disappear as soon as I turn off the Docker container? What distribution are we using? I mean, we're using Kali Linux right now. So the changes are persistent. They persist. They should persist. Okay, so if they do persist, then we can just make it like a root bash, right? So it's like, oh, I forget how to do the root bash thing. Hold on. Yeah, make a root bash, put it in temp, and then they will persist until the image is removed. Oh, okay. Just making simple SUID executable. I need to look up the syntax for that. Okay. Okay, I think I've got it. Oops. So copy bin bash into temp, and then give it the permissions. ID RSA on in the directory SSH. Okay, so this is what I'm gonna do. Move into temp, and we're gonna copy bin bash, and I'm going to turn it into a file in the temporary directory called root bash, and then we're going to make it a SUID binary. Okay, and then anybody who runs root bash should get a root shell. Okay, what I was saying is you could push a public key into authorized keys for root. I mean, we could. I think. Yeah. Okay, I mean, we're able to get root access and then read the root. We're able to get root access and read the root.txt file, so I guess we can consider this over. I'd like to figure out what the proper path would be to maintain some persistence. I mean, it might be to crack the root password, but I'm pretty sure the root password isn't really crackable in this case. How do we maintain persistence? Because all of the file stuff reverted afterwards. Where was that actual command? So the command we used was this one right here. I'm going to copy it. I'm going to copy it so that we can use it later. Thank you very much for the follow on Twitch, ImagineFlow. Thank you. If there's an SSH, just drop in SSH authorized keys. I mean, everything that we did reverted after we... Everything that we did reverted afterwards. So the root bash thing that we created, it disappeared. I mean, it exists inside the Docker container, but it doesn't... April, no worries, and thank you very much for coming by. And thank you very much, Aravind Campbell, for subscribing on YouTube. To how to find API for Recon? API? Check out these education links over here. Claretto says, what, does it all the time in the videos? Oh, are you talking about dropping in... Each user has its own temp. Each user has its own temp. I mean, I don't... Maybe. I mean, if each user has its own temp, then maybe what we need to do is we just need to put it in the... We just need to put the root bash in in the top level directory. Like this. Drop in the users. I mean, we also put it in the Marcello users. So home Marcello. It showed up. So it is persistent. So we just need to run root bash. Now we're the root user. So we completely rooted the system. Great. We can wander on into the root directory. We're in the proper system. We're not in... Want to know the best process for collecting information from a network? I mean, El Molaz, hello, nice to see you here. Are you talking about what kind of information? Well, I mean, you're talking about enumeration, right? Are you talking about for a website or for something else? Anyways, we're just about finished, but we managed to completely finish this. I guess I'll do it again. Redeem. I'm root.
What are you?
I'm system root.
And we can spam the flag emote. There you go. Have you checked your CPU and memory and GPU usage on the host running OBS? That's maybe that is why the stream is crashing. But yeah, we managed to finish this. I'll do a write-up when I've got some time, but thank you very much for everybody for coming on by. We managed to finish this box completely, so I'm happy for that, and thank you very much for everybody's assistance. So, Sick in the Mind for suggesting the command to mount the local file system to a Docker container. And yeah, alright, so let's talk about what we're going to be doing next week. Not next week, next stream. So today was Web App Wednesday, and the next stream we're going to be doing is on Friday, and we're going to be doing some intro to AD breaching. So we're going to be doing more Windows stuff. We're going to be doing more digital, what was it? Disk image forensics. We're going to be doing more of that. We're going to be doing some PCAP forensics. It's going to be a lot of fun. You pwned the bank, buy some Bitcoin to invest. Yes, of course. But yeah, thank you very much, Von Borg, for suggesting something we can look into. And let's see if we can find some fun people to raid on Twitch. The best people, the best streamers for InfoSec are on infosecstreams.com. Here is the link over here. And MSec is on. I wonder what MSec is doing. Sometimes MSec is doing some kind of esoteric stuff. Let's check it out. Okay, MSec is doing some... what is this? Building a parkour-focused social media site with Claude. Okay, we're gonna send you over to MSec, and hopefully he's got some fun stuff to talk about. He's building that app. Yeah, okay. Let's start the raid. Raid, MSec. Okay. Alright, everybody. My name's The Shy Hat. I do cybersecurity stuff on Twitch and on YouTube. We'll be back on Friday, so please come on by at the same time. But on Friday, remember everybody, hack the planet, and HackerFrogs out in 5, 4, 3, 2, 1. See you next time, everybody.